Hello, everybody, and we are live again with another chit chat show. Open panel this evening, believe it or not. So, if anybody wants to join, I will be posting a link in the chat within the next 15 minutes. So, if anybody wants to hop on, they can. And also, if you're a member of the Discord, you can just hop on immediately. We have a few people in. Right, the hand says 1 like, 29 dislikes. The bots are out. Yeah, that's before the show even starts. Thumbs up for the dislikes, I guess. Mind of God, Christian Kumar, Liam Bobrick, Anthony Burrows, Mike Dornan, Myrelm, Utzin, Storm Williams, TMF, Page 42, and Amanda Young. Hey, everybody. Right, okay. We are joined by Spurs Chemo and Ruhif. How are you both doing this evening?
Hello, lovely.
Good
I
evening.
can't sleep, so yeah.
So what's it?
Good evening, Ranty. Good evening.
So
good evening, Ruif.
It's evening for
Good
us.
evening.
So what's it for you, Ruhif? Early morning?
6:30. Yeah, 6:30.
Wow. Okay.
Yeah. I've been waking up at like 5:30 most mornings the last week or so.
Is it going to be a hot day today for you down there?
Me? No. It'll be like 15.
Yeah, that's kind of not bad.
It's cold. It's cold.
Here in the UK, we're quite happy with 15.
Yeah, you guys are soft.
Oh dear me. So we've got a few more people in. So we have Debate Flat Earth and More is in. Congrats on your passing 1,000 subscribers and being able to monetize your channel. Well done. Flat for Life is in. Super Dave got a nice little channel going there. So if you ever want a shout out from his channel, I think he kind of links channels with other channels and he shouts them out and people go in the chat in his stream and then everyone seems to subscribe to everybody. So if you're looking for a few more subscribers whenever Super Day 44 goes live, you shout your channel out, and guaranteed you will get a few more subscribers. Obviously the crux of that is that you have to subscribe to them too. But you know that's his little thing over there that he does. So big thumbs up to Super Day for helping out the smaller channels out there. Right, okay, so let's get into this. Spurs Chemo. I want to say you've been around the block recently, but that has some kind of weird connotations when you say it like that. But you have been around a bit. Do you want to tell us about what's been going on?
Well, like you said, been around a bit, and luckily, in the last week or so, there's been a PhD, and I've had a conversation with Fight the Flat Earth and Team Skeptic. And it's been quite interesting. It's been an interesting discussion with the PhD, especially going through the scientific method. He said he was a scientist. He doesn't know what science is, doesn't understand, the independent variable. So that was interesting. And then obviously the Black Swan was even more interesting and eye-opening because he'd never seen such an observation before. And he described it as refraction of a different character. Which was, humorous, say the least. So, yeah, that was an interesting discussion with PhD scientists.
I call it refraction of a different degree.
Yeah, something peculiar it was called. But obviously, refraction. We can get into all that in a second there.
Yes.
Yeah. So then I obviously started with Fight the Flat Earth. Team Skeptic there. And there was a challenge to demonstrate liquid absolutely flat, perfectly flat, 100% flat, measurably parallel. And I was able to demonstrate that. There was a £1,000 bet. 500 from Team Skeptic, 500 Fight the Flat Earth, 500 from myself. So I ended up showing them a glass company which showed liquid glass 250 meters, absolutely flat, absolutely parallel. And they just couldn't believe what they were seeing. And they believe it followed the curvature of the Earth. But the guy in the video said it followed the flatness of the tin, of the canal, of the bath there.
Wow.
And if they're going to make such a wild claim against what we see, with my citation there, and they're going to have to demonstrate that it's not following the flatness; it's actually following the curve of the Earth. So, yeah, that's basically pretty much. I'll obviously talk about finer point.
So when are they gonna? Are they giving you the £1,000 or is it going to charity?
To charity, yeah.
Okay,
so obviously,
So when are they going to hand that money over?
Well, this is it. You see, they're refusing to pay because they have a belief. They believe the Earth is curving. They believe that the glass is following the curvature of the Earth with absolutely zero demonstration. I mean, if something is parallel, I think any surveyor could tell you parallel is 2 points, and then obviously you can figure out if it's level, where you'd force the line, not level as in curve, because Craig was trying to outline that level means curve. But in this sense, we're talking about parallel, where you have the completely straight, like a straight line, so to speak. And they're refusing to pay. It's very upsetting, obviously, because it means that the Earth is not curving. So we'll just see where it goes from there, really, and we'll see what happens next. Right.
Okay, right the hand. Can we do a quick mic check there? Okay, right.
No.
So Ruhif, what do you think about this? I mean, have you seen this this video that Spurs is talking about?
No, I got no idea what he's saying. What is it? Glass is flat. Like, I don't.
There's a company.
Stick a link in there.
Well, basically, there's a company that makes this is it glass Spurs chemo that they make at the end of it?
Just regular window glass, yeah, just glass.
Okay.
Like we don't see curved glass, do we?
So they heat the glass or whatever it's going to turn into the glass up. It runs through a canal. I think the canal is 250 meters long, and basically it explains it in the video that it's perfectly flat over this 250 meters.
Okay.
So how do you explain that?
I've got to see what you're talking about first. Like, I've got no idea at the moment.
Spurs, do you think you could present the video?
Yeah, let me find you. Yeah. And then you can obviously put that in the chat and then Discord. Yeah, so essentially, Ruif, it's just like we're told, water or liquid is not perfectly flat, right? It curves.
Right.
Yeah?
Yep.
Do you still stand by that statement?
That water curves? Yes, of course I do.
Yeah. Okay, so we're able to demonstrate that liquid over a allotted distance is absolutely flat. And
where does the glass come into it?
Sorry? Yeah, there's the video. So if you want to see the act, you can go to the last 2 minutes or the last.
Yeah, where's the link for it, Spurs?
I'll put it in. It's there. I'll watch it.
I put it in general chat. Where's the main chat?
Oh, right, in general chat. Right, okay. I see. Right, okay. So let me get that ready to play. So you say it's the last 2 minutes?
Well, just go to the last part and then it will show what we were talking about. And then we'll see.
Okay. Yeah, no, but I can only listen to one thing at a time. So
okay.
Going to take 21 minutes off? Or...
Put a camera.
Yeah, you don't have to watch the whole thing. I said go to the last.
How about, Yeah, but how about I watch it later when I can?
Well, I can play it for you now if you like, or for the audience.
Go to 20 minute. I'll tell you where to go. Go 20 seconds. 21 20. Yeah. 21.
I'm going to hit the deaf and mute.
Okay. Yep. So 21:20.
21:20. Start from there.
Right. Here we go. So I'll start from 21:15. That's good enough.
Sorry. Yeah. 21.
Here we go.
Parallel. That will match that glass flat. Remain absolutely flat and parallel.
What's that?
Oh no, I might go forward a little bit more. So I've got 21, 25. You can go from there, yeah.
21:25. That's the end of the video.
Sorry, 20:25. 20:25.
20:25. Right. Okay.
Yeah.
Okay. All right, here we go.
Leaves the conditioning end of the melting zone at a temperature of 1100 degrees centigrade through a narrow canal, from where it passes to the heart of the process.
Spurs. I'm playing it. What is it?
Go back a second more. You've gone started a little bit more.
Go back to 2020.
Yeah, from here. That's
right. Okay, so Ruhif, if you can watch this video, right? Cool. Here we go.
The glass leaves the conditioning end of the melting zone at a temperature of 1100 degrees centigrade through a narrow canal, from where it passes to the heart of the process, a bath of molten tin.
Get there in the end.
Here the glass spreads out, following the perfect flatness of the tin, so that the upper and lower surfaces of the glass remain absolutely flat and parallel.
Got it?
Yeah.
That molten.
Yeah, that's pretty conclusive. There, let's just go back and just listen to that important part again. Yeah. Pop yourself. Yeah, just let the audience listen to this bit again. Just keep quiet a sec.
Here the glass spreads out, following the perfect flatness of the tin, so that the upper and lower surfaces of the glass remain absolutely flat and parallel.
Boom. That's pretty devastating, isn't it?
Here the glass spreads out, following the perfect flatness of the tin, so that the upper and lower surfaces of the glass remain absolutely flat and parallel.
No curvature, right?
Yep, I agree.
And that's the problem that they're having is, well, it must be curved. Flat now means curved, see?
Well, they're saying that it follows the tin. So the tin is obviously flat, right?
Right.
And it's 250 meters long, and it stays parallel and level with it, yeah?
Mm-hmm.
To give you a flat window, so obviously you don't want to see a beveled window, do you? Now,
all right, I'm back.
Yeah.
Hello, everyone.
Now, if there was Earth curve, nobody that constructs these buildings or these foundries or whatever it is would make something 250 meters long, because they would know that the liquid metal or liquid that they're using would be curving to the gravity of the Earth. It would have it wouldn't be completely flat, would it? Mm-hmm. So nobody would build it 250 meters long.
So, Ruth, what do you think of that? Do you think flat now means curved?
I don't think flat means curved, but I will say that I don't have enough information to go on. Just repeating those couple of words at the end isn't enough evidence for me to go on. So I would need more info.
Like what?
Like the source video?
No, but what would they say to you? What would they would say? Yeah.
Like how do they verify that it's completely flat? Like we're talking, I think it's like half a centimeter or something of curve over 250 meters.
Well, yeah, I mean, I think over 10 meters it was 0.7 millimeters, I think they came up with. Something like this. So, do you think that's detectable?
0.7 millimeters?
Yeah.
I don't know. Probably.
So, do you think they would have... Do you think they would know?
Yes, we can hear you now.
Yeah. Okay. Do you think they would notice that, Ruef? If it wasn't absolutely flat, do you think they would notice?
It depends. I don't know.
On what?
I would need to see how I would need to see how they measure it. I'm asking for more information.
I know. I'm asking what kind of information? What more? Do you mean you have to work
see how they measure it? Yeah, to see how they do it, how they measure it. More information.
Do you have glass companies in Australia?
I'm sure that we make glass here. Yes.
Okay. How do they do it?
I don't know. I'm asking for more information.
So if it could satisfy you that it was absolutely flat, what would it tell you?
I don't know.
Okay.
I think that's disingenuous.
I don't give a shit what you think, Travis.
Chemo, are you making any plans to contact this company? I would be I wouldn't be surprised if they would give you an interview. If you would say, "Hey, I watched a video. I've just got some questions, and I'm an investigative journalist." Blah blah blah.
No, I haven't. Well, there's been a little bit of effort, I think, to make kind of contact. I think Craig says he's contacted them, and I'm just waiting to find out what the answer is or the response is. So, I mean, again, if flat now means curved, how do we know when something is flat? What have you ever seen anything flat before, Ruif, in your life?
To what accuracy?
I don't know. That's what I'm asking. Have you
that's what I'm asking.
Have you ever experienced anything flat?
My desk that I'm sitting at looks pretty flat to me. Is it perfectly flat? To what degree of accuracy is it flat? I don't know.
But
this is what I'm asking.
But I'm asking, what does it mean?
No, this is what I am asking.
No, you've just said perfectly flat. I'm asking, what is that number?
I didn't say perfectly flat.
No, you said, I don't know if it's perfectly flat.
I don't know.
So what number? Ruev, calm down. I'm only asking, what number is perfectly flat? When you say something is perfectly flat?
It depends to what degree. If you get down to a molecular level, nothing is flat.
So there's nothing ever flat.
Right, at a molecular level. But what degree is acceptable?
But
that's what I'm asking of you.
No. If nothing is never flat, can that be the same for curvature? Or does that mean...
No, because we know the degree of curvature of the Earth.
Mm-hmm.
It has a radius of 6371.
Yeah. But flatness, we can never measure that completely.
What degree of flatness?
0 degrees. Is that,
no, you can't measure perfect flatness to anything. Because when you get down to it, you got molecules that are not flat.
So what if you just iron them out?
Well, you can't.
Why?
Because you can't iron a molecule.
It's too small.
Well, so I don't know what you mean. So if you've got the glass and you've got a bubble, you iron the bubble out, there's no bubble. Are you saying there's still a bubble?
To what degree is the glass flat? To what degree of accuracy?
Again, flat. It just means no curve, nothing.
Yeah. No bumps in it?
What degree of accuracy do you guys say for the curve? Is it like 5% something? Alberini was within 5%. So is that okay for us?
5% is quite huge. Do you know what eccentricity is of an ellipsoid is?
Sorry, I missed that.
The eccentricity of the... Who's got the feedback?
It's probably me. That's why I went straight back on mute.
Ah, cool. So the Earth is not a perfect sphere. It has an eccentricity. So it's a ellipse. And what is the eccentricity? It's like 0.003 or something. Hang on.
What about
that describes something that's not perfectly circular.
What about parallel, Ruif? What does that mean?
What about parallel?
What does it mean to you, parallel?
Parallel, I think, can have two meanings. So one meaning is that there's two straight lines having the same distance apart, or there are two curved lines with the same distance between them at all points.
Two curved lines?
No.
What do you mean, two curved lines?
Like concentric circles. There's a definition of parallel that you could apply to that.
No, that's not parallel.
Well, then we're using a different definition. That's okay. Let's just clarify.
Well, clarify that. How are we using?
Well, it depends what context we're talking about.
Well, how do we apply practically these curved lines?
What the concentric circles? Under some definitions, you could call those parallel lines.
No, but I'm asking about the practical world. How do you apply it?
Depends on context. What context are you talking about?
Any context in the practical world.
You're the one asking me what parallel means. You have a context. I'm wondering which context to apply it in.
So you can use parallel, you can use plumb when you're building something, when you're looking for a straight line. How do you do this with curved lines? Where do you do this?
If you're building something, then the context is obviously two straight lines parallel.
to straight lines, yeah, but not curved lines.
In that context, no.
So I'm asking, where in the practical world do you use curved lines?
The curve calculator?
No, in the practical real world.
Yeah.
Yeah,
exactly.
what's the word?
Can I chime in with something real quick here? Curve calculator, is that measuring curve or is it measuring drop?
Both.
Oh, I'm going to have to disagree with you here.
All right. Who are you?
All right, so here, let me explain why. If I have, let's say I have a distance, okay, it's from here to over there, and I take a physical ruler, put it on the ground, and measure that distance. That's a measurement, right?
Okay.
Okay, now if I look at that distance and go, it's probably about 8 feet. That's not a measurement. That's an optical, I'm looking, right?
Right.
Okay, so tell me where you measured. Now, I just want the measurement of curve, not of vision. So I can take the ground right here in my backyard and I can measure it flat. That's a measurement of the earth flat. Show me your measurement of curve.
All right. I went to California last year, actually 2 years ago now, I think, and measured from my observer location off to a distant peak, measured the angle to it, and using the elevations of both of those, calculated the curve.
Oh, well, I said measurement. You did a calculation.
Yeah, you had a calculation.
Yeah. So okay. So see, maybe you were on this. So a physical measurement means you use a physically standardized thing, such as a yardstick, such as a rolling. I don't know if you know, they use it's like a wheel, and it tracks how many times the wheel turns. That's a physical measurement. Yeah, exactly. So where's your physical measurement of curve, not a calculation based on vision?
I measured the angle to a distant peak. That's a measurement.
No, but that's a vision. You're looking at the peak, which is curved lines, which is refraction. So you're not getting a physical direct measurement. That's a vision. That's visual.
How would you measure it?
It's apparent. It's apparent.
I'll tell you how I'll measure it. On the floor, just like I did. So I have the earth physically measured as flat. You have some vision. Do you see your problem?
No, how would you measure curve if it existed?
Well, if it was there, I would take the floor, right, and I would start walking on the floor, and then there would be a dip, a deviation, right? I would start, things would start looking tilted away because I was on a ball.
No.
I would measure that. I would measure that tilt away.
No, they wouldn't.
What do you mean
because
they
you're
wouldn't?
down.
If you have a ball,
the direction of down changes as you go across the earth. So you wouldn't measure a dip.
Whoa!
You're assuming that.
Yeah, that's incorrect.
No. Yeah. So don't. Let's not make assumptions, because when let's say I'm measuring, I'm walking. Okay, I'm walking. I'm doing.
Therefore, you think I'm upside down right now.
No, I don't. Here's the thing.
Well,
so
then the direction of down changes.
We're on the same level.
No, it doesn't.
You're not upside
assuming
down.
that.
You're not upside down.
On a
hold on.
globe.
Can I jump?
Do this
well, yeah, but
without assuming
we're looking
anything.
for the physical. Yeah, physical measurement of you going upside down. Where's that? Where's the physical measurement that you were right side up, went 1,000 miles, and now you're, or to whatever it is, and now you're upside down? Where's that physical measurement?
On a globe, do you understand that the direction of down
on
changes?
A globe.
Okay.
Yeah. That's great.
Asked,
I understand. Now show me that in reality.
I've just asked how he would measure curve, and he goes, you'd go through a dip, and that's wrong.
Well,
you would not measure curve like that.
Okay, if I was on a ball,
right.
Let's say I was let's say the Earth was 100th its size, I could measure the curve very easy, right?
I'm asking you, how would you do it?
Yeah, you would take something flat. You would use water to build something flat, okay, and then you would lay that flat thing on the ground and see if the ground deviated.
You've just said you'd use water to build something flat. The water would
liquids
curve
lay
as well.
flat. Yeah,
no, they don't.
No, it doesn't. But water doesn't.
Water doesn't curve.
Yes, it does.
See, we can have that. Show me this. Show me water curving around a ball.
We don't have. Yeah, we don't have.
No. We need to clarify, everyone. Hold on. With Ruhif right now, we need to clarify what each of us is meaning by water curving, because if he brings out a raindrop, that has curvature to it. We're not talking about raindrops.
The bubble in the level and
Okay.
I mean,
can I share screen?
We can visually see. Okay, if I can see the difference between a straight line and a circle, right? We don't need to tell how different they are. We know that the straight line is straight and the circle's a circle. So Where is this
The
circle?
problem-
Like, this is all I'm
The
asking.
problem is, right, the hand, he thinks that as you walk around the curve of the ball, gravity is acting on you to then tell your body you are straight up all the time, no matter, even if you're standing on a fucking golf ball and you take a step to the side of the golf ball and you fall sideways, in their paradigm, you're still straight up.
Yeah, but when viewed from another person.
Okay, so Ruhif wants to share his screen, is that right?
Oh, I've just posted an image in the chat.
Oh, right, okay, no worries. I'll try and post it. Is that in the general chat?
Yes.
Okay.
That is what I call proximate looming, Ruhif.
I honestly don't care what you call it, Travis.
Yeah, it's refraction.
Okay, but this is visual. This is a visual. This is not a measurement. This is, and this is exactly what I was talking about.
You asked.
This is
you asked
looking
for
at
curving
something.
You
water.
don't know where that horizon is. You don't know where that horizon is.
It's after the first boat and before the second boat.
Okay, the distance. You don't know the distance. If you're going to claim that that is the curvature of the Earth, you have to know the distance of that line that you see.
I was asked for showing curved water. That's curved
not
water.
curved water. It goes it's
Then
horizontal.
where is the bottom of the boat?
It is behind refraction. That's what I just told you. Listen very carefully. Listen. Okay, hold on.
Ruhif,
Let me
Black
hold
Swan.
on, Paige.
I don't
Hold on,
actually
Paige,
listen to
please.
you, Travis.
Paige, please hold on. Please hold on. I just have two quick questions, Ruhif. In the Joshua Nowicki photograph of Chicago, is it your opinion that Chicago is visible because of refraction?
Yes.
Okay. So, I have three questions. So then, does that mean if that refraction weren't occurring, then Chicago wouldn't be visible?
I'd have to do the calcs, but I'd assume a little tiny bit of it would be visible.
Okay. So, is it your opinion then that in the way that refraction can bring up a distant horizon, is it your opinion that it's possible that refraction can also raise up proximate distance so that you have a false horizon higher, making the horizon closer to you?
I have no idea what you just said. Explain to me from the bottom of that boat the path of that light.
No, you can't do that. You're asking for...
No, you can't do it. You
can't do it either.
I can have a go at this. I believe that boat was anchored, right? The one in the foreground was anchored.
Yes.
And the one in the background was about 10 kilometers or something like that, 12 kilometers behind it. Yeah. And it was in shallow waters, the one that was, I say shallow, much shallower than the one that was in the deeper water. Shoaling, Ruhif. Shoaling caused that
Shoaling?
Yes.
Shoaling.
Yes.
Okay,
Shoaling
Ruhif.
caused...
That is a thing we've measured. It's a thing that we know happens. Why would you laugh at that?
Because this guy is 10 meters above the water. Do you think you can see a 10-meter hump? You remember Ranty got across Morecambe Bay?
It's
and
refraction.
I sent you that photo.
It's refraction.
Yep, bit of refraction,
Yeah,
shoaling, bit of downward refraction. I know you want to say upward refraction, downward refraction, but do you know what? I'm sick of playing your games. Down means down, up means up, and that's the way I'm going to work it from now on. So downward refraction. Downward refraction.
Ruhif,
Sinking Ruhif.
See how you twist everything?
Yeah.
Ruhif, you see this picture you've just posted? You said, where's the bottom?
No, Ranty's talked about shoaling, and I wanted to show you how stupid that is, right?
Really? There's a shoaling calculator out there. If you want to use a shoaling calculator...
I understand there's a shoaling calculator. I would love to do a video about shoaling one day.
So why is it stupid?
Perhaps you should look into those shoaling calculators.
You guys are talking about water not curving, yet you are saying there's at least a 10-meter hump in this water.
Okay, if you're in a bath and you flick the water with your hand, does it create a hump?
Is there a permanent 10-meter hump in this
If you're in a bath and you flick the water,
not permanent.
Does it create
it goes
a
up
hump?
And down.
If you're in a bath and you push the water, yeah, of course it does. Are you in a bath?
Cool. Well, is the ocean still? Is the ocean still?
Does this video show you 2 minutes of the hump not moving?
Is the ocean still? Or is it moving?
No, of course it's not.
Right, so it's a constant...
Does water find its level or does it not?
A shoaling effect is a constant
yes, it
push.
finds its level. It continues to try to find its level. Yes.
I find the shoaling
Always.
hilarious because you keep saying that water doesn't curve, and yet there's always this
Who said water doesn't curve? There's wait a minute. There's who's tapping
Right,
there?
yeah, we didn't say that.
Who's tapping?
Not me. I think it's Paige.
Okay, stop tapping.
Sorry, I was playing with the corner of my phone. Oh, sorry.
Right, okay, so you got waves. Waves hump. Are you going to deny that waves hump? Why do you want us?
Don't deny that waves
when we say the Earth is flat and we're talking about flat water and stuff, why do you always put us on a flat surface, utterly flat with no waves in it, nothing? Why do you do that?
Oh, I always say get above the surface. Always.
That's not the point. The point I'm asking you is, you've just turned around and said, when have we said that we don't see curves on water? We've never said that.
Permanent 10-meter hump in the water.
We know the topography of the land. The topography of the land underneath the water shapes the water above it.
Yeah, very close to the shore. It does. Yes.
No, it does. Not necessarily very close to the shore either.
Yeah, but you're talking about swells coming in and then shoaling into actual waves, right? Watch the boat in the foreground. It doesn't move. There's no swell.
We know that. We know that doesn't move.
Okay, so there's no shoaling.
This is in the shallows. That's in the deeps. Shallow,
and the boat,
deep.
And the boat in the foreground is not bobbing up and down. There's no visible.
Okay. Can you tell me how?
Hold on, Ranty, I got it. Hold on, Ranty.
Yeah, he doesn't get it.
Hold on, Ranty. Yeah, okay, Ruhif, listen.
I've done a couple of presentations about shoaling, Ruhif. Maybe you should watch them.
Yeah,
no, I did, and then I did a bit of research on it, and then let it go.
Okay, just real quick, Ruhif. Basically, what he's saying is that the boat that's closest to you isn't experiencing the same aquatic effect that the distant observation is. There's distance there.
Yeah, but he's called it shoaling, and shoaling is what happens when you get close to shore.
Okay.
So this is closer to shore.
No, it's not.
Closer to shore.
No, it's not.
Yes,
it happens it happens anywhere that there's an incline. Now that's why I've said
to shore.
No, you have a volume of water and you have a ramp. When you've got a force acting on that water, it's going to be either being pushed up the ramp or down the ramp, and it's going to have an effect on that.
Yes, and that effect happens the closer you are to shore. Therefore, it happens to the closer
It happens everywhere that you have a ramp, Ruhif. Where you've got a steep incline.
Are you saying there's the far boat is shallower than the closer boat?
No, that's in deeper water, Ruhif.
Yeah, so the closer one, would be more.
Yeah, Ruth, you're just. It seems like you're just having fun. I mean, look, we both know.
I am. Yes.
Yeah, you're having a bit of fun here. So we know that horizon there is not physical, right? We know that tomorrow. Well, if we have
moves with the weather,
we have observations that show.
Yeah, but it's still water. It's still a physical thing.
Okay, listen. This is why.
Yeah, but Ruif, hold on a second. Ruif, we're talking about measurement. You're looking at something where you think it's obstructed by water or physical obstruction. So the only way to verify that, obviously, would be to measure.
What is hiding the bottom of the boat?
Well, what are you asking me for?
Refraction.
Because I'm telling you the water is hiding the bottom of the boat.
But I know you're telling me that, but I'm saying, do you have a measurement to that
water?
point?
Yeah, that's what we're saying too.
Hold on a second, because he's telling me, and I'm saying, okay, how do we verify your optical visual illusion? Can we get a measurement from our observation point to that location? Because what I'm trying to say to that horizon, because we know tomorrow, Ruif, that will not be there. It could be more of the boat.
Will still be there. That water will still be there. You might see it at a different point.
But the horizon will be.
Have you not heard of the black swan there, Ruif?
I've absolutely heard of the black swan, Spurs.
So what have you heard about the black swan?
The horizon actually above eye level because of severe refraction.
What have you heard? You've heard the horizon is above eye level?
Yes.
What do you mean above eye level?
Well, you have eye level.
So
the horizon appears above it.
That's not the point of the black swan.
So the horizon.
You know what the actual point of it is?
Hold on. Let's go back to your picture with the boat. So you're saying, Ruif, that physical line that you're saying is covering that boat can now be behind the boat.
It can, depending on the atmospherics. Yeah, it can.
So you're saying that that physical water that is covering the bottom of that boat could be behind. How does the physical water?
No. Not the physical water moving. The last point of water that you can see will be different on different days.
No, but you see where it's
Yeah, the
obstructing.
horizon.
You see where it's obstructing the bottom of that boat. We can't see the bottom of the boat, right? Because there's physical water. So yeah.
Right. Yep. So
So
water is blocking the boat. Good.
how comes on another day, if that boat was anchored there, didn't move, we knew it stayed there at 9 miles, how does the physical water... So we're in the same position. We haven't changed height. We haven't gone closer. But that hard horizon has moved. How does that happen?
Refraction. Refraction lets you see further.
Refraction can't move a horizon. It can only
Ruin.
Absolutely. You're different. You're seeing a different horizon.
Yeah, but I'm trying to figure out how this works. So you've got this physical obstruction, so the physical now moved behind the physical boat.
You're just seeing a different horizon than you saw the day before.
So where did this horizon go? The one that's in front of the boat?
It would be now closer to you, like a little bit lower in the image, like where the front
so
boat is.
That physical water has now moved.
The physical water hasn't moved. You can see further because refraction has flattened out the curve.
So how did it make something physical disappear?
Nothing physical has disappeared. The water didn't disappear. It's still there.
So why can I see the bottom?
You say the horizon is a physical
Hold on a
thing
second,
that
Paige.
blocks
Paige, hold on. So how is it then now I see the bottom of the boat and the horizon behind it then?
Say that again.
So we've got the physical horizon in front. Now the next day we've got the horizon behind it. How did that happen?
Refraction has flattened out the curve. The stronger the refraction, the more curvature to the light ray.
You're saying light can move a physical object?
No. You just see further. The point that you see where the tangent, where the light hits the lowest point is now the new horizon. I'll stick a link, one sec. Yep.
Hey, Ruhif, I'm just curious. Are you aware that I did a pretty reasonable analysis of this footage?
I think I saw it, and I think it was gibberish, so I don't really care, no.
So you just hand-wave dismissing because you're not dealing with my arguments.
Yeah, Travis.
Can we get back to this point a second? So, Ruth, you said refraction. So, you know we have a gradient, right?
Yep.
So, it's warm air at the bottom. The lowest layer is
generally, yeah.
It's a warm layer, and then you've got cold air above it, right?
Yeah, that's the general direction, yeah.
Or do you think can you have colder layer at the bottom and then warmer at the top?
You can, yeah. That's an inversion, and that creates very strong refraction.
So
that's false.
So hold on. So what would be the gradient then? If you've got cold, warm, cold, how does that work? The gradient.
How does that happen in reality?
If it's dense at the bottom, but you're saying no, it's colder, so that'd be less dense, right?
Yeah, but you've got pressure as well. The pressure's pretty uniform, decreasing.
Yeah, but I'm saying, is it less dense at the bottom?
Almost, unless you're seeing upwardly bending light like an inferior mirage.
No, I'm asking about
almost always the case.
I'm asking about a gradient. Can it be
no,
the
you
case
asked about the density.
Yeah, but I'm asking about the gradient. Can it be a case where there's a cold layer at the bottom? So if we've got a can and there's a gradient or whatever, can we have a cold layer at the bottom, warm at the top?
Yes.
How does that happen?
How does it come about?
Yeah.
Generally, the water is very cold, and then it turns sunlight, and the air gets heated, and the water's still cold.
Okay, any idea what we're looking at here, Ruhif? I've brought the video up in question, and I've just paused it.
Where do I see it?
I should be sharing it in the Discord. So if you just go to the show channel.
Show channel. All right, cool.
Okay, yeah. So I've just paused it as the boat has passed the boat in the background, because you had a screenshot of just the containers. Yet when you actually the boat passes it, we see the front of the boat. Why wouldn't you present this? Why wouldn't you present this image as opposed to the image that you presented, which didn't show the front of the boat and the bow, etc. You know, my question is, why would you just show us or show my audience an image of just the containers apparently sinking behind some water, when you could have quite easily showed this part of the video that shows it clearly not behind the same amount of apparent curvature?
I think if you get photos of the boat, you'll see that the front of the boat is higher than the back.
You're missing the point.
I'm sure there is some. I am sure there is still some missing of the boat. I'm sure of it. Positive.
Yeah, okay. Good.
Positive that there is still probably 30 feet, perhaps, or so of that boat that's still.
So what's the difference?
That's still.
You sound like you're accusing me of something.
That's still missing. My point is, you're showing a boat that's just showing an image of just containers, above the water, and Travis is spot on.
So you think that more is missing?
Yes.
So what Randy's point is that if you have a visual on the bow, then there's not as much missing as you want us to believe by presenting us an image where there is no bow, so that you think that there's more of the hull missing. My question real quick, Randy, is can you back that video up before it passes behind the one ship, and do you have a visual on the bow then? I'm just curious now that you brought this point up. I appreciate that.
No, you don't, anyway.
I don't know if we do. I know it's out of focus. Well, we do. He's not zoomed in. He's not zoomed in though, and it's a bit out of focus. You can see the front of the boat there. The boat there. You can see that's where the bow would be. It's all very misty and murky there, actually. To be fair.
Right. So.
And he's not zoomed in. When he zooms in, further on, Yeah,
you can see like a meter of it.
If I could, I'd like to just bring up one of the points that I think is pretty reasonable, that no one has actually addressed. Everybody just hand-wave dismisses. You know that, Randy. Everybody just hand-wave dismisses our analysis. But what I would like to point out is that this image is twice the distance as Critical Think in another video. Critical Think shows another tanker in Perth, I think it's Perth, and the distance is half. So he's closer to this tanker that he's showing. But the angular size of the containers is the same. And yet, this one here is twice the distance. You wouldn't have containers that remain the same size if one of those container ships is twice as far away. That's a point that I brought up as an observation. It has yet to be addressed or challenged.
We talked about it, Travis, and that's one of the reasons why you've got no idea what you're talking about.
Okay, so the reason why I was saying
that's a hand-wave dismissal.
Yeah, but then how did you measure the angular size on both of them? That was my question, and you completely failed to answer it.
It's visual.
We went through this months ago.
See it.
It's not visual. Measure it. Measure it.
See it. Measure the fucking horizon.
I did.
No,
I
you
was
didn't.
just about to say the same
No,
thing.
you didn't.
We want measurements
I've
too,
measured the
not
angle.
calculations.
No, that is not a measurement. That is not a measurement.
I have measured the angle
That
to the
is not a
horizon
measurement.
many times.
That is not a measurement.
Yeah, we're done, Travis.
Yeah, you're done.
So, for example, Ruif, if you look at this image here, which horizon would you measure your angle to?
Are you sharing a different image there,
But yeah, this is in general chat. This. How do you explain this? How do you explain this image, Ruif? Got the same height,
can
different
you make it bigger?
Bigger. No, maybe this one.
I got it. It's all right. I'll just measure the horizon to wherever it is.
But you've got one. Well, how far is? Well, where is it?
Well, I can easily see it in the left one. The right one's a bit blurrier, but I can still see it, and it's tiny.
Okay, so how do you explain this picture?
Different refractive conditions show you a different horizon.
Okay, so what's refracting over what?
Air is refracting through the atmosphere.
Air
is refracting. Oh, sorry, light is refracting through the atmosphere.
Light is refracting.
Yeah.
Around what, Ruif?
Around the Earth.
Okay, so what
around
in
his presupposed curve.
but hold on, in the image, what is so we've got we know the lighthouse is 9 miles away, so it's in its locate, hasn't moved. So what is refracting? Sorry?
The platform, you mean?
So the platforms, the platforms are oil rigs here. They're 9 miles away. They haven't moved. So what's refracting exactly?
The light refracts in different density gradients.
Which object is refracting?
Both of them.
I'm asking you, name the object?
The oil platforms.
The oil platforms are refracting over around what? How? Where?
Just say what you want me to say, and then I'll agree or disagree.
You're saying refraction. I'm asking you,
and you're not making sense.
Exactly, that's the point, because you're not making sense. The picture on the left, yes, you'd have the physical horizon. In order to see the bottom of that physical horizon, you would have the oil rig refract over that physical horizon, right?
It will flatten. Refraction causes causes the curve to flatten out.
Okay, guys, so I'm just going to do a couple of shout-outs here. So Cleary says, and I will get to say this when Ruhif has finished with Spurs, any topographical maps with measured curve. All right, so I will get to ask him that, I promise you I will do that. We also have from Darwin a $10 super chat, says, I apologise for being late. Please start from the beginning. Rehearsal's over. Lovely jubbly. Thanks, Darwin. And we've got Unatoxfezimo, Two Horizons or Reflection of Physical Horizon. I want to know anyone who wrote anything about this bullshit in human history. I want to read all that books. Thank you for the super chat. Right, back to the show.
How does that work?
Physical measurements of a ball. All you have are pictures from NASA that have been proved.
I never use pictures for NASA, by the way.
Yeah,
no.
How does that
why
work?
you believe you're on a ball, because
No,
they've shown
it's
you
actually
pictures
not.
from space. It is.
No,
That is
that's
the
not.
only. It is.
Paige, don't
do
tell me
not
why I
have-
believe things, Paige.
You don't have physical measurements. You don't have a physical horizon. The only physical thing you have are pictures from space.
That is not what I use at all, Paige. Don't put words in
I
my mouth.
didn't say you use them to argue. What I'm pointing out is, in the back of all of your globe head minds, you have this thought that, we've got pictures from space. So no matter what I'm arguing about, even if I'm arguing about refraction or whatever, I must be right because I've seen the Earth from space in a picture.
I don't care. The pictures of space, you can call them as fake as you like, and I don't care.
Okay,
I do
then
think they're
show
real.
me some actual physical proof of the ball, not a horizon that moves with the weather.
Okay, I measured the stuff in California. The angles to distant mountains match the globe.
You measure it on another day, the horizon will be somewhere else, and you will get a different measurement.
The amount...
No.
Look...
No, really, no. The horizon doesn't move on a daily basis, depending on the weather.
When I measure, I'm trying to be nice.
Come on. No.
Trying to be nice.
If you went back the next day, would you get the exact same measurement? No.
You said the horizon.
That's our
I'm not
point.
measuring. You said the horizon. I'm not measuring to the horizon. I'm measuring from my observer location to a distant mountain. I'm doing it far enough above the surface so that refraction is relatively consistent.
But what are you measuring? The height of the mountain down to what?
The angle to the mountain. And then I make two predictions. I make a prediction for what the angle should be on a flat Earth and what the angle should be on a globe with the dimensions.
So you presuppose your flat Earth as well as your globe Earth?
That's how it works. That's how science works.
No, science elucidates the cause of an effect. You don't assume anything.
You were talking about measurements there, Ruhif. Ruhif, you're talking measurements, not science. You're talking measurements, not science. So
hypotheses.
No, we're talking measurements. Remember?
Hypotheses are guesses.
You don't hypothesize when you take a measurement.
I'm talking to Paige. Hypotheses are guesses. I guess that the Earth is a globe. If the Earth is a globe and my guess is correct, what should we see in reality? If the Earth is flat, What should I see in reality?
It should be, I see this effect. What can I do to elucidate the cause of this effect
Yeah,
without
and you're making and affirming the consequent fallacy doing that.
But no, you
Ruth,
are.
how-
You're saying
you
if
had
I'm on a globe,
hypothesis
I
of
should
a
see
globe.
this.
You had a hypothesis. Okay, how did you try to falsify your idea?
Oh, by making many, many measurements.
Okay, so where are those measurements?
Oh, I spent 2 days in the desert doing this. I have measured a shitload of stuff in Sydney here. All of it
Did you
is
not
consistent with the
document it?
globe.
Did you document
I
it?
made videos. I've made videos, yeah.
So that's what I'm saying. Can you show us how you measured those angles?
Oi.
Sure. Do you want to play my 20-minute video during the stream?
Well, just give us the timestamp or the points where you got you got the conclusion or how you did it. You can, let's see what you did. Let's see how you verified where the physical horizon was.
I didn't measure the horizon in this one. Oh, sorry, that's Jay Tollins. Hang on.
Right, listen. We've had a couple of super chats. The last one, well, actually, I'll read Cleary's out first. He says, "Ruhif, any topographical maps with measured curve?" ?
Any topographical maps? I'm pretty sure topographical maps are flat, aren't they?
Topography refers to the surface of the Earth.
Indeed.
Yeah, but they're elevations. And elevations refer to...
Elevation is not to be confused with height from center of the Earth.
If you want to
elevation is not from the center of the Earth.
If you want to say topography is flat,
enough.
If you want to say topography is flat, that's fine with me.
So, Ruth, can you just give us a timestamp where you tried to falsify your idea? Yeah.
Okay.
By making measurements.
Okay. Well, before we get into that,
I want you to say, look, this is my idea, and this is me trying to falsify my idea. Obviously, that's what science is in your idea, right?
I have another super chat to shout out. One second, guys.
I falsify the flat Earth.
Aaron Armstrong says, hold on, guys, one sec. Right the hand. Arwin has turned his comments off. He's writing notes every 2 to 3 days, but all they contain is watch history from the day before. That was from Aaron Armstrong, right the hand, so that was a super chat. I don't think the super chat was for you, though, even though he's at right the handed. So, can you just clarify if that was for me or for right the hand there, please?
That was just not the money's not for me. I just told Arwin to start taking notes, and I've come prepared, so good to see you doing.
Right, okay, so let's get this video up. So have you posted the link there, Ruhif?
Yes, I accidentally posted Jay Tolan's original first, but mine is there now.
Yours is there now, right? Okay, so
another JT Tolan one.
Yeah, another JT Tolan. Yeah. Is that right?
So this is you, Ruhif, falsifying your idea, yeah?
Done properly. Ruhif and Steve McRae, is that it?
No, you're not, Ruhif, you're not proving the globe. You do realise that, yeah?
I understand better than most people that you cannot prove anything.
Right, so you're trying to this video should be showing us
science proves the cause of an effect.
Science does not prove things.
Yeah, I understand that.
Does.
No, it's okay. That's how they see it. In the heliocentric world, that's how they see it.
Pseudoscience, yeah.
I can accept that.
Yeah, that doesn't prove anything.
But now we have to try and falsify this, Ruhif. So how are you falsifying, not proving you're on a globe?
Yeah, if the Earth was not a globe, I would get a different measurement, different angle.
If the Earth was not a globe, you would get what?
I would get a different angle. Much different angle.
Let's see it then. Let's see how you tried to falsify.
Right, okay, so have we got any timestamps, or is there anywhere you page, tappy tap tap?
Oh shit, sorry, oh my god, I was
hold on, Ruhif.
sorry, I do that so often. Oh my god.
Does this angle prove a globe or falsify a globe, Ruhif?
It didn't falsify the globe.
Does it prove a globe?
No, you can't prove the globe.
Does this angle show we're on a globe?
Does it what?
Does it show and demonstrate we're on a globe?
It is entirely consistent with us living on a globe. It doesn't prove it.
That's not what you're trying to do, Ruhif. You're trying to falsify that you're on a globe.
Yeah, if we weren't on a globe, I would get a different angle.
Yeah, but you're demonstrating that this angle is on a globe. So you've got the
Have
idea of a
you
globe.
measured a flat
So
plane to see that it wouldn't be that?
hold on, please. You've got the idea of a globe. And this angle works on a globe, so you're already within the idea of a globe. You need to
that's my
falsify and
hypothesis.
show. Yeah.
Yeah. If we were not on a globe, I would get a different angle. How do you not get
That's
that?
not how. No, that's not how you falsify. If you were not on a
And when were you on something that wasn't a globe to measure the angle and make sure?
Well, I'm not on
Or
a
you
globe.
just assume what you would see on a flat Earth.
Saying this
Okay.
angle, this angle works on a globe. You're still hypothesizing. You're still guessing.
Yeah.
Not falsifying, Ruhit.
There are two hypotheses, right? I
So-
could have ignored. Listen, I could have ignored the globe hypothesis and just went out and said, I'm testing the flat Earth hypothesis, and then measured the angles, and I would have falsified the flat Earth hypothesis. Yes.
No, that's not how you do
That's
it.
exactly-
You've got your globe, you've got your sides, you've got your angles. All of this works in the idea. Now you're trying to show this is not the case. So, what's the size of the Earth, for example? What's the size of the angles tell us?
6371.
Right, so that means that from the observer height, there should be a horizon at every point. So if there's not that horizon, Ruif,
This has nothing to do with horizon.
no, but this is what I'm trying to say. This is how you would falsify your idea of a globe, curving globe. Remember?
We've got a bit of feedback. Yeah, got a bit of feedback going on.
All you're doing is repeating your own hypothesis by saying, this is the angle that shows we're on a globe. This is the measurement.
I'm falsifying the flat Earth hypothesis.
No, you're proving a globe.
No, I'm falsifying a flat Earth hypothesis and demonstrating that my measurements are consistent with a globe. I'm not proving the globe.
But Roo, if you use the R value and your 7/6.
My hypothesis is a guess.
You don't. Hang on. Can I finish? You don't have a physical horizon to measure to get your R value in the first place. That's our problem.
I don't listen. My hypothesis is a guess.
Hang on. No. I could go out, do the same measurements, do the same, measure the angles and stuff, then say, okay, on a flat Earth, we have, whatever refraction I can make up, whatever math I want, like you guys have, and say, okay, this works on a flat Earth, just like you've said, it works on a globe. We've got 7/6R. Okay, we've got 14/9P. Like, it's ludicrous. You haven't got a physical horizon to create that R value in the first place. Just like you don't have containment to create pressure in the first place. You want to argue about what happens afterwards, but you haven't proven the first premise.
You're talking like that refraction is just made up and the 7/6R is made up. It's not.
It is. Your R value is made up. My God, Ruhif.
Getting back to the science.
He can't measure a physical horizon. It moves with the weather. What day did he measure his R value?
Did
he go back the next day and the next day and the next day and the next day and in winter and in autumn and in spring and in the rain and in the sun? And did he do it? No. He just picked one day, said that's where the horizon is, that's its physical measurement, that's our R value. Bullshit.
For the fourth time, this experiment does not measure the horizon, and I'm getting far enough above. Well, I am.
I'm talking about you using refraction to give you your bendy light, your 7/6R. That's what I'm talking about. You created that 7/6R from your R value that he took a measurement of a physical horizon that moves with the weather.
Are you trying to channel Nathan here? Is that what you're doing?
Oh, fuck, I hope so. He's brilliant.
Oh, he's not.
Okay, right, listen.
Right. How do you measure something that moves with the weather and give it a specific value? You can't.
Right, so what are you... Right, okay, so what I would like to do here is... I'm just going to jump in for a sec, and I want to ask Ruhif to explain... in a second, actually, there's a couple of super chats, but I want him to explain what this video is demonstrating, the tools that you're using, what sort of things you were trying to elicit from it, and what was the results at the end of it. So basically, you can just sort of like run through it quickly, with hopefully, and then we'll get some clarity on that. But the super chats are, Cleary says, nobody has ever measured curvature, never ever. And Aaron Armstrong says, that super chat was for you, Ranty. Well, thank you very much. Tough luck right at the hand, you missed out there, mate. Unlucky. Better luck next time. Right, Ruhif. Do you want to explain to us what you tried to achieve with this video, and what your conclusions were from it?
Right, to test two hypotheses. One was that the Earth was a globe with 6,371 kilometer radius. Other one was a hypothesis of a flat Earth. On those two possibilities, I calculated what the angle between my observer location and a couple of mountains should be. So the angle to the mountain on a flat Earth should be this. Angle to the mountain on a globe of this size should be this. Went out and actually measured it and compared it to predictions. And guess what? My predictions of a globe. My predictions of a globe were pretty accurate.
Go ahead.
In fact, at the end, it's about 18 minutes. Where are we? Hold on. There's a graph I did at the end at about 18 minutes or so.
Okay, I'll get to that.
Okay, so this is great. This is the point, Ruth. So you're saying your conclusion is globe. So now you're saying the only way to falsify this is to use this method, use these angles.
1850 or so.
Yeah, I've got it up. It's on the screen for everyone to see.
Cool.
Ruth, so you're saying that now we've got these angles and it says it's a globe. Are you saying now the only way to falsify this is to what? We have a globe. So the point is that your result is globe. So if somebody said, well, I want to falsify this now, this idea, because I haven't verified it, how would they falsify this? This is the only way. What?
What would you do? I mean, I've measured the angles of mountains and they're consistent with the globe, so that doesn't falsify it. What would you like to do?
Well, if it's a globe, it would have a physical horizon, right?
Yeah.
Where things disappear consistently.
Depends how close you are to the surface as to the consistent part.
But we would have a physical geometric horizon.
When you say physical geometric, I agree with the physical part. When you use the word geometric, are you assuming no atmosphere?
No, we're talking about an object that has geometry to it.
Okay, yep.
Okay. So, for example, let's say you got a basketball, something disappears behind it, observer.
Sorry, Paige, can you mute, please?
Let's say when you add the atmosphere, what happens to that? So the boat's half missing, no atmosphere. You add atmosphere. What goes on? What's the difference? What happens to that geometric? Yeah, what happens to that geometric horizon? Where does it go?
The light curves, and it pushes the horizon further back. Light curves down generally.
Light curves down and pushes it back where?
Back further.
How far?
Depends how much the light curves.
Or how far? What's the limit?
What's the limit to light curving? The light can curve more than the radius of the Earth. So the light can curve stronger than the curvature of the Earth.
I know this is all part of your hypothesis. Remember?
No. Yeah. No.
What's no?
No. Light you can measure so that the refractive index of air with a certain temperature, pressure, humidity, CO2 content can be measured incredibly accurately. All right, that's been done in a lab for decades. If you can then go,
you're telling me your hypothesis. Remember?
No, I'm telling you that refraction is measurable if you have good enough equipment.
Yeah, but anything that you say, unless you can demonstrate it now, we just have to assume that somebody may have done it. Jesus may have walked on water. There are witnesses. Do you know what I mean? We just don't know up until we show now.
You don't know that people have measured the refractive index of air?
Yeah, that's what I mean. We can assume people have done that, but unless it's repeatable, like science, we don't actually know, right?
Done in a lab. These are lab measurements first.
I know, but it's not like something you could show now, is it? Right?
I don't have video of it. No,
exactly. That's
scientific literature papers.
That's what I mean. It's not on tap. Not on. You can't just say, "Oh, let me see the evidence." That's something that's just like an idea until we have. The
you're doubting that people did this, is what you're doubting, right?
Well, no. I'm sure you think.
Well, if you're not doubting people did it, then that's established then, right? We can know the refractive index quite accurately.
No, I'm not doubting that you believe
Okay.
there are people out there who have done it, and I'm saying, okay, there are
You
people
doubt
out
there are people out there who've done it.
No, again, people believe.
Do
Jesus
you doubt it?
Do you doubt people believe that Jesus walked on water?
I doubt that Jesus walked on water.
But do you doubt that there are people out there that believe that Jesus walked on water?
Of course there are.
Of course there are, right? But that's my point. So up until somebody shows that, like right now, you're not going to believe that, are you? That's the normal thing,
Jesus
right?
walked on water. No.
Right, exactly. So just like you saying that someone has done this is hearsay. Unless you can show me right now, obviously you can't. I can't show you Jesus walking on water. You can't show me your evidence right now. But obviously we have to go by, it's just our hypothesis, yeah?
It can be repeated.
For goodness sake.
Jesus walking on water cannot.
Well, of course it can be repeated. When Jesus returns, it'll be repeated.
Are you actually a Christian?
It's not about me, but I'm saying it can get silly like that.
He's got a good point,
the point what I'm saying though, Ruth, is that it can get silly like that. I could start going, I can do this,
and you are making it silly.
But that's the point, because you're making it silly. I'm asking you for what we can do now, in the present day, in real time, and if we can't, we just have to accept it's just an idea that we think
hundreds, if not thousands, of people who have over
millions,
the decades measured the refractive index of air.
Yeah, and I'm just saying that hundreds of people saw Jesus walk on water. They saw him die.
Actually, it's only the who was in the boat. Peter was in the boat.
No.
Was it the apostles in the boat?
Yeah, I'm sure there were loads of people around seeing all these.
Yeah, interesting that no one reported that. Mark didn't report that Peter walked on water. That was interesting.
Probably too shocking. Didn't think anyone would believe it.
Or Matthew just made up shit, right?
Just like what you're telling me now. We'll never know.
Yeah, people make up shit, don't they, Ruhiv?
We can go and get
How will we ever know if Jesus walked on water or if you can prove the globe? How will we ever know that now?
If I had the equipment, I can show you that the refractive index of air under certain conditions, I can demonstrate.
If I had a time machine, I could go back and show you when Jesus walked on water. But that's a big if, right? But right now, Ruhiv, I'm talking about the now, the real time, present day.
Yeah, this is silly. Do you accept that they can measure the refractive index? Yes or no?
But that's my point. Right now, we can't show your hypothesis to be true. Right now, can we?
Yeah, and I'm saying that it's absurd for you to just dismiss decades of research into refractive index. That's absurd.
Well, it's absurd for you to dismiss thousands of years of biblical, knowledge that have been put out there. The amount of churches that we have, the amount of religious people. We have a Sunday, Saturday worship. It's just absurd, Ruth. Again, that's just me saying that my hypothesis versus your. See what I mean? You're just giving me your religious idea. Yeah. I'm giving you my religious idea. It's not how
I understand where you're going, and that degree of absurdity, is something that reasonable people can agree on. And you are being unreasonable.
Well, what's unreasonable? We both are in the same position right now. We can't demonstrate right now in real time our claim. We think we can.
It's unreasonable because you're making him look unreasonable.
I say in the future, when Jesus returns, I'll be able to demonstrate it. And you're saying in the future also, when you get your evidence, you're able to demonstrate. So we're both in the same boat, Ruth. What's the difference between me and you?
Yeah, because you're making an extreme, not category error, a degree error.
But what's the difference? Mine is in the future, yours is in the future. I can't do it now, you can't do it now. What's the difference?
But we can demonstrate in the near future. I can go and buy these things and do the same experiments, right?
Jesus will return very soon. Very soon.
Yeah, but he won't, right?
Very soon Jesus will return. What are you talking
about? Look, I understand your point.
But there are people who believe he will. Absolutely.
Very, very soon.
They have no doubt.
Could be tonight. Could be around the corner.
Just like you have no doubt in your ball.
So again, Ruth, we're both hypotheses are in the future, right?
Yeah,
but
I understand your point, but you're being unreasonable.
But again, I could say you're being unreasonable because you're talking about the future and I'm talking about the future.
Hang on, just admit your allegiance to evil, Ruhi, if you may as well.
See how difficult it is, though? We're both in a religious idea. You're supposed
to say... It's not a religious idea. I can demonstrate mine.
Well, I can demonstrate mine.
No, you can't, because you can't demand that Jesus come back.
Of course I can.
Okay.
No,
Make
but
him come
we've
back
got
now.
books written about it, saying what he did,
Well,
where he
can't do
walked,
it.
who he
It's
talked
getting
to,
very
just like
ridiculous.
you've got,
I mean,
they
right
measured
now,
the
in
R
this second,
value.
I mean, you're asking right now. I mean, I don't know about right now, but maybe sometime in the future, yeah, sure I can.
Yeah, right. This is getting ridiculous.
Exactly.
You can get,
This is how ridiculous your
buy-
religion is, right?
you
Because
can buy a refractive
look, let me educate you a little bit. When you argue religious belief, right, you get nowhere in life. If you have one idea versus another idea, it becomes ridiculous. See? So you may as well not start.
You can go and buy the equipment.
Mhm.
You can do the lab test yourself. All right. Now,
You're
this
just being
I
ridiculous
understand your point. I understand your point,
You're
but
being
it's
ridiculous.
ridiculous.
Exactly, because you know I can mirror everything you say to me. I can mirror back to you. You can go and pray. You can go to a church. You can go and speak to God. Any of these things. You could say no, you can't. I could say no, I can't. You could say you can. Da 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 da.
Yeah, and then I can demonstrate it to you.
No, but you, the guy who's making the claim, needs to be able to prove it, Ruif. Right?
I can
Not me.
demonstrate that. I can demonstrate that the refractive index can be known very accurately.
I can demonstrate Jesus is coming very soon.
No, you can't.
Neither
Because
can
I
you.
can actually go and do it.
But we've
I
demonstrated
understand.
your R value.
This is getting ridiculous, right?
No, Ruif, I'm trying to show you how much of a child your brain is like. You're not
No,
thinking
I
like an adult.
understand your point. I understand your point.
So if you understand, grow up, mature, and say, right now, I cannot prove to you my idea. Right now. Man up, then we can stop this childish game.
I've said many thousands of times, you cannot prove anything. Okay?
Well, you can't
If you want
demonstrate.
me to say, I can't prove
demonstrate
the
it,
refractive
right?
index to you, I can't prove the refractive index to you.
Yeah, you
I
can't
can point you
demonstrate
to
a thing
decades
about
worth
your
of research.
Just
I
be
can
honest,
point you
Ruif.
to decades worth of research where people have measured the refractive index very accurately.
Ruhif,
Well,
this
you know that
how
religion
did
has
they
been
measure
around
that?
for a lot. Last point, George. So, Ruif, you know that last point, George. You know that religion's been around a lot longer than your scientific heliocentric idea. So, there's no reason that you would believe your idea versus this idea. There's absolutely zero. Go ahead, George.
Whatever. Yeah.
this is quite absurd, Spurs. I mean, this whole idea of waiting till Jesus returns. You're waiting for one man. You're basing everything in this religion on one book that cannot be reproduced.
You're basing yours on a globe that can't be
Paige,
reproduced.
please, Paige. I'm not interrupting you. The thing is, those Spurs, as Ruhuf says, he can measure the index of refraction. Maybe not at this very instant, but within a week we could set up the tests to do that. You cannot do that with this walking on water business.
Yeah, I mean, look, Jesus could return tonight. You know, we just don't know.
Yeah, then by next week we'll show you.
Man, we're saying we can arbitrarily, with arbitrary number of people or arbitrary person, go ahead with the proper equipment and go measure refractive indexes. I mean, it can be done on demand. I mean, not at this very instant. We would have to gather up the right equipment, but we could do it within the week.
So what made Alberini choose that particular day, that particular horizon to measure and get his R value? Why did he decide on that day? Had he already done
Hold on
exactly?
a second, Paige. I don't want to lose this a second.
Refraction.
Paige, please hold on. So, Ruif, you get the point now, then, right? You recognize that you've been brought into.
I recognize that you're an extreme denialist. That's the point that I'm making.
I'm not denying anything. I've asked you to.
Okay, so let's accept it for the sake of argument that we can measure the refractive index.
Well, why don't you just accept Jesus?
Because I'd reject Jesus. I'm actively rejecting Jesus.
No, accept.
Yeah, but for the sake of argument.
You said just accept it. What you just said. Why? Is this a religion I should just join a cult? Why should I just accept it?
Because do you deny that we can actually go out and do this stuff?
Why should I just accept what you've just said? Why?
That the refractive index can be measured.
Yeah, why should I just
accept that he should just accept it?
Because we can go and do it.
Accept it.
The threshold.
Until he sees it for himself, why should he just accept it?
Because he should understand that people can, by themselves, go out and do it themselves easily.
Yeah, he says that. He said, fine.
Okay,
but
so
until
is that a reasonable threshold to accept?
Yeah.
Yes.
It's
okay.
not that.
Yes.
It's that he's saying, should you just accept something without seeing it?
Is that a reasonable threshold, Spurs?
Yes, I've accepted you, but Ruif,
Good.
I've
So let's
accepted
stop
you have a
fucking
belief.
talking
You have a
bullshit.
no,
and
it's
get onto
not.
it.
I've accepted all of that. Again, we're in your hypothesis stage. I accept all of your hypothesis, every last bit. I accept everything. Why should I believe it if you can't demonstrate it?
But it's trivial to demonstrate, and that's what you should understand: is that we could go out and do it, just as many thousands of people have in the previous decades.
Could yeah. You could also, pray to God and be a good Christian, be a good person, but you choose not to. A lot of things you could and couldn't do. Are you doing them though? Are you demonstrating your claim? That's what we're
Yeah,
looking at.
look, let's move on.
It's difficult, right? And that's the point, you see, Ruif, right? Is
Yeah,
you're just
just
bringing this.
obfuscating, Spurs.
You're going to have to concede, Ruif, right?
I concede that we can't prove things. I conceded that years ago because I understand science.
No, demonstrate. You have to concede. You can't demonstrate your claim.
I can do. You just said you accepted it.
No,
But
I
we
accept.
can go out and get this equipment. We can go out and do the experiments.
No, I accept that you're saying you can do these things. Whether to
Yeah.
believe you or not is a different matter, right?
Okay, is it a reasonable thing
You
to accept?
understand? I believe in Jesus. You write why? Okay, because obviously he saves our soul. So, but to believe in you, why? What have you done for me to believe in you? I accept you say you're God, or you can do this, or whatever. But why should I believe in you?
Yeah, this is getting pretty ridiculous.
There's no reason to believe in you, right? You're just a man. You have an idea. You want me to follow you. You want authority over
No,
me?
I would love if you went and got this equipment and did the experiment yourself. How good would that be?
Well, I would love if you turned to God and started to pray.
Well, I think the Bible's shit, so no.
Your religion is just the same, Ruit. This is
I don't have a religion.
Can you demonstrate you don't have a religion and you have practical demonstration?
Ruhef, can I say?
Yeah, correct.
You're getting tired, Ruif. Okay, so let's move on.
Okay, so while you've been arguing about Jesus, I made a search in YouTube just as a normal guy, and I found a big list of how to use the tools and get the refraction index.
Hey.
Thank you.
Fantastic. So I think we're big on demonstrations, Ruif, and like if people just run around with their ideas, kind of bothers us because why should you be the authority in what is and isn't without?
I'm not the authority. I'm telling you can go out and do it yourself.
Again, telling me.
Yeah.
You are the authority, telling me. Why are you not showing me?
Go and demonstrate it to yourself.
Why are you not showing me instead of just telling me, bossing me around, controlling me? I'm the authority. Just accept it.
Yeah, I think we're done with you as well, Spurs.
You see, it's ridiculous, Ruif. And that's what we do. We're able to show that you guys literally have. Do you know, I wanted to start a new show called Are You Smarter Than the Flat Earther? Because it doesn't seem that any globe earther can outlast, outwit, outthink, or just compete with any intellectual, free-thinking person. You find yourself stuck now, Ruif, wanting to give up and move on to someone else who you'll be able to handle a little bit easier. You see, but reality is that we're able to.
Maybe he could tell us what the refractive index is, right? Maybe we could start there.
You okay with that, Spurs?
Yeah, I'll go make a quick cuppa.
All right.
Yeah.
So right
yeah,
then,
okay.
in a lab, the refractive index can be measured with extreme accuracy. Right? You get the pressure, temperature, humidity, and CO2 content. And over decades of research, they have refined all those measurements into a formula. And that formula is accurate to like 8 decimal places for the refractive index. Then.
Okay.
Yep. Okay. So then you take atmospheric data, which I got from weather balloon data. And the weather balloon data gives you temperature, pressure, CO2 content, humidity. From the weather balloon data, you can work out the refractive index at each measurement that the weather balloon takes. And because you can work out the refractive index at each level, you can work out the gradient in between those levels, or the average gradient between those two levels, and therefore work out approximately what the curvature will be for that ray of light.
Okay. Do you remember what question I asked you?
No, because fucking Spurs just went off his fucking tree.
Okay, because you didn't answer it. I said, what is the refractive index?
It's the change in angle of light, or change of speed in the light as it changes from one medium to another, or one density to another.
Okay, so the refractive index is the change in the measured change in the speed of light, right?
Yep.
Okay, so let's, I guess let's start at the beginning. Where did we measure the speed of light? Let's do this.
I don't know, and I don't care right now.
So, yeah, so you have nothing. Congratulations. So, so when you were, okay, so you don't even have, right? Remember we were talking about religion. You have, when we peel all the layers back, you have nothing, absolutely.
Okay.
Right? Because you were just like, oh, speed of light, I don't know. I don't. Okay.
Yeah.
There you go.
Do
you heard
do you know everything? Do you know everything?
Yes,
Hey,
I do actually, because I have God.
Yeah.
Ruhep, I might mention it's very easy to measure the index of refraction without having to measure the speed of light differences. All you have to do is build yourself a air dielectric capacitor and measure the changes in capacitance, because that follows the change in permittivity, and permittivity determines the refractive index.
Okay, George, do you agree that the refractive index is the speed of light changing based on the medium?
Yes, it's related to that.
Okay, so you would say that in order to prove this claim, we would start with establishing that light is an object that moves with a speed?
Have you measured the speed of light right there, hand?
It's not my claim. This is your claim.
No, I could do a Spurs, but I won't.
This is why I don't say. This is why. Hold on. Here, hold on. Let me just say. This is why you don't say Jesus walked on water without any proof. You're saying the speed of light thing. Now it's going to be on you to prove it, not me.
I was just going to say that the speed of light is inversely proportional to the square root of the permittivity of the medium that it's traveling in. So by knowing the permittivity, you can determine what the speed of light is, and permittivity is very easily determined by measuring the capacitance of a parallel plate capacitor, in which the air is between the plates.
I'm sure you can do a whole lot of electronic things. I want to see the physical.
Things that you don't understand,
Hold on. Let me. Okay, tell me what I don't understand.
Whatever George said.
Okay, well, no, because he went off on a tangent. So I'm talking about before you can have a refractive index, which is the change in the speed of light through a medium, we first have to establish the speed of light. Now, before we can establish the speed of light must be some kind of thing that is moving, because you can't move nothing, right? I can't determine the speed of nothing, right? So first we have to establish light is some kind of object that can even have motion, right? So I'm getting to the real crux of what you believe in. And this is where you're going to say, well, light doesn't occupy space. And we're going to say, well, if something doesn't occupy space, then it doesn't exist in reality. And then how are you tracking the speed of it?
Who are you asking?
No, I'm not. That wasn't a question. That was more of a statement. Like you can't track something that has no occupying of space properties, because then it's not existing in reality. And this is what you're telling us, right? So we could say the same thing about angels. Like, yeah, angels are real. They don't exist physically. They're not physical, but they're real. And you're going to say the same thing about light. It's not physical, but it's real.
May I just say something? So I've got I'm developing some augmented reality software at the moment, and for exact placement and scan data for point clouds, the iPad that I'm using has got a LiDAR sensor on it. The LiDAR sensor fires out 30,000 points of IR light at a sample rate of 60 hertz, and it measures the return speed upon hitting an object. Now, due to the constant of the speed of light, it's able to sense the 3D world, and this is how I'm going to say 70%, because some are actually pure optical, but 70% of LiDAR-based autonomous vehicles use exactly the same tech. This is a known thing.
Okay, but that could be what you just did there. Was you didn't show me the movement of a physical object at 187,000 miles per second. What you did was you made a calculation based on the delay that your sensors gave you.
Correct.
Yeah, it's consistent with the speed of
Okay,
Earth.
so
That's what it
correct.
was.
Okay, and he agreed. So we agree that delay in electronic sensors does not equate to an object moving at 187,000 miles an hour. Second,
like I've said a
so
million
what we
times, you
need.
can't prove anything.
Well, no, hold on. Well, I can demonstrate that this board right here, I got this flower garden. I can demonstrate it's 4 feet wide. I can demonstrate that to you very easily. I'll take a ruler and I'll show you
You come back and say, this is 4 feet long because I measured it. And I will say, if the board is 4 feet long, you will measure it 4 feet long. It measured it 4 feet long, therefore it is 4 feet long. And I will say that's an affirming the consequent fallacy, right?
No, hold on, that's not a fallacy. Okay, so you're trying.
This is
hold on. Hold on, explain. So what we're doing when a measurement is not a fallacy, is that what you're trying to tell me?
Yeah, but the measurement doesn't prove that it is 4 meters long.
Whoa, hold on. Before you rambled, is a measurement of a physical object a logical fallacy?
No, it's a measurement.
Okay, so measurements are not logical fallacies, right?
Okay, but still, go and prove
Okay.
that your thing is 4
So
feet
hold
long.
on. Okay. So if I measure something and it's 4 feet long, did I commit a logical fallacy?
No, you just made a measurement.
Okay, and are measurements empirical?
Yes.
Okay, so I made an empirical measurement of 4 feet. So where's your issue?
You said you could prove that it's 4 feet long.
Okay, what does empirical mean?
Just measured.
Oh, no. So empirical means measured.
Empirical means direct observation.
Yeah, better.
Okay, so could we say?
But again,
well,
right, the doctor, which is weird saying that. But the point about this is what I can do with that LiDAR sensor, or what it's doing, is it's giving me a point cloud. So it's giving me loads of little 3D points in 3D space by measuring the real, as in the return speed. What I can do to simply invalidate this, if that was not true, is when I move back twice the distance, it would invalidate it quite easily if it wasn't true. If I move back 5 meters, it would invalidate it quite quickly if it wasn't true. Yet it accurately, and when I say accurately, at 5 meters, you've probably got about 3 millimeter error tolerance there at 5 meters, but close in at like 2.5 meters. On the iPads, you can have units that do it a hell of a lot better than this. So yes, it's sensor return of the delay of that EM signal coming back. And yes, it is just a delay. And yes, I can't see. Well, I suppose I can see the effect of the infrared going out. If I got an IR filter and took a photograph of it, I'd see a lot of it. In fact, I could do that. Except I haven't got
okay,
that.
but hold on.
Next week
hold
I'll
on.
do that.
Okay, wait. That was a long monologue, but you got away from what we're talking about, which is the measurement, the empirical, right? Observed in reality. Now, empirical measurement of light moving at 187,000 miles per second. Now, you could say whatever you want. You agreed I could measure something empirically. Now, if you can do that with a piece of wood, you're going to have to do that with this light moving at 187,000 miles per second.
Your 4 feet piece of wood measured at 4 feet is consistent with the wood actually being 4 feet. It does not prove that the wood is 4 feet long. Do you understand?
Okay, so what does prove mean? Well, okay, but here, I have a different definition of prove than you probably do. Okay, so prove is that's a self-belief, right? I can't prove anything to you, right?
Okay, we're in agreement.
Yeah. Okay, so now what we need to do, do you agree that I can demonstrate 4 feet of wood to a standard of 1 foot per 1 foot? You know what I mean? Like how big 1 foot is, and then 4 of those. You agree?
Some degree of accuracy, yes, yeah.
Yeah. So now let me see what you're measuring, right? Because if I didn't have the wood there and I was like it's 4 feet long, you would be like, what is? I'm like, well, you can't see it, but it's 4 feet long. So first, what are we measuring? Show me it.
I've forgotten even what this conversation's about. What's the actual
speed
thing
of
we're
light?
measuring?
Yeah, speed of light.
I don't
We're
know.
trying to
Ask
measure the
George.
speed of light.
Here's a question for you, right? The hand.
Well, hold on. Don't ask me a question.
Okay.
Wait,
Okay, I'm going to make a
my
statement.
point, or
I'm going to make a statement. I can use an ultrasonic measuring device to get very accurate measurements of between 2 walls in my house, and it does so because it knows how long it takes that sonic wave to propagate through standard air from one side to the wall and then back to the sensor. That's exactly the same as the light, and it is a measurement. It's just using a different stick.
No. You're getting a readout on the display. So what I want before you're jumping ahead. Hold on, you're jumping ahead. No, I don't want consistency. What I want is I have a wood and I've measured it. Okay, hold on. I have the wood and I've measured it. Now, before we can measure anything, show me what we're measuring.
Distance.
Okay, so we're measuring. So you're saying we're measuring a distance. Okay, so what is the distance that we are? What is the distance that we are measuring?
From the sensor to the object in the straight line vector that the little IR shot out at. The infrared.
Okay, so now distance is inches, feet, miles. What is the distance?
The space between two things.
Yeah. Well, so give me. Well, can we satisfy in an inch to make it easy?
Oh, can we use centimeters? I hate inches.
Three,
so it says
3
like
centimeters.
48 inch.
Okay.
I don't know what the hell that is.
All right. Whatever. So now we have 48 inches. Now what? Where's the speed of an object come in?
So the speed of an object, you can determine. So do you know what speed is?
Yeah, speed is an object moving, right?
No, I'm saying, do you know that? Yeah, exactly what Ruhi said.
Yeah. Okay. Hold on. Let me ask you something. Can you have speed without an object moving?
If you're not measuring an object, yeah.
Oh no! So you're just making something. So you're just making up I can make up 10 million miles an hour, right? Is that the speed of an object?
Are you measuring? You wanted to measure an object speed now? That's not what we're measuring.
Well, isn't light? We have to measure something, right? You're saying you're saying this light is an object.
Yeah, particle. Yes.
Well, whatever it is,
it's not like a train. It's not like a taxi. You don't call it and then tell it to go.
What? More like an angel? Is it more like an angel?
Is light an object?
You're telling me. You're telling me you measured its speed. Why are you asking me questions now? It seems like maybe you're unsure.
Can we not measure the speed of a wireless signal from A to B, classified as ping or circuit time?
No, that's delay. That's not speed. Delay and speed are different.
No.
Delay and speed. Hold on. Let me ask you something. Let me ask you. Thing right? Is delay? Is delay and speed the same thing?
So in going from A to B to A, yes, it bloody damn well is.
Okay, so speed and delay are the same thing. No. Wait. Okay, I have a question. I have a question.
The same thing going from A to B
with
the delay.
Okay, so let me ask you one question. So let me ask you a question. If speed and delay are the same thing, why are they different terms?
No, with the delay that the signal has going from A to B, then B to A. He's
just trying to say that you assume that something's moving. That's all he wants you to say.
Wait.
You assume
something's moving. No, because I can create delay without an object moving. Watch for the delay. You saw that? There was a delay. Now, where's the object? Where's the object that was moving? We had a second delay in between these pulses, but there was no object moving. There was no object that went from A to B to A to B. So what you're doing is you're creating. You believe it. You believe it. So this is why I'm saying there's a difference between the delay and the motion of an object. So did you measure delay or motion of an object?
So can you just
no. Hey, can you answer that question? Can you answer that question? Did you measure delay?
I need to get clarity.
No. Wait, hold on. Okay, so let me clarify. So I'll clarify.
Really bad.
So I'll clarify. Okay, let me clarify. Delay would be time in between specific event. You have A, then you would start the time, then you would have B, you would stop the time. There is no motion of object, you're only tracking time. Now, speed would be the motion of an object over the distance that it has traveled. Now, did you measure speed, the motion of an object over the distance it's traveled, or did you measure delay?
Object, we are measuring the delay over distance of a signal going from A to B to A. This is very well understood.
Okay, so a
with
delay.
Electronics.
Okay, so you measure a delay. You measure a delay.
Travis's mic out. Travis, your mic's a little bit high.
Oh, sorry. Okay, so we have established that you didn't measure the movement of a physical object that can slow down. You measured electronic delay. So when you go back, and we bring this all back to the refractive index, which he says is the light slowing down, you can't apply it because you have the delay in electronic equipment, not light. So I'm going to have to call bullshit on this one.
I think you've completely misunderstood the point.
No, we were talking about the refractive index, which went to the speed of light, which came back to this experiments in delay, which is why we connected it, right? Were you here? Maybe.
Okay. The IOR value is actually over the speed of light. It is the fractional reduction in light speed. Yes, it's very.
Yeah, I know. Okay. Yeah, great. So, and what we're doing is we establish that you don't have the speed of light. You have electronic delay.
Delay is
now,
how we measure. Delay is how we measure. Radio signal speed.
Yeah. Okay, but you didn't measure the movement of an object.
No.
Right.
No.
So how do you know it's
radio
slowing
signal
down?
is not an object. And no,
yeah,
it's
I
not
know.
down,
But that's not the radio signals have nothing to do with the refractive index. We're only talking about the mechanism
radio signals
behind
have a lot to
the
do with refractive
Hold on.
index. Radio
okay,
signals
but hold on.
get refracted as well.
I know. So here's the point. So we're talking about the refractive index, which refers to the slowing and speeding up of light through mediums, right? Which, when we actually look at your experiments, doesn't move light through a medium. It measures the electronic delay within that medium. Now, then we translate that back into outside, which is observation over long distances that have nothing to do with electronic delay. So why are you bringing that up?
I get it now. So if we go to a scan place and get scatter and absorption coefficients of the transmit of light through mediums and measure them and the delay that it takes over distance, in other words, working out its fractional reduction in speed, the one thing that totally invalidates that is if we make it 3 meters. Now it's gone. It's out the window. Sod that. We can't extrapolate that. Oh no, maybe 3 miles. We can't do that either. No, it's just out. That's such shit, dude.
Yeah, that sucks. But you didn't measure an object moving.
Yeah.
You don't
You're
have
just trying to get to the point that we have to make inferences to the best explanation, that we can't prove things.
Well, maybe somebody could inference God is creating light. Maybe
would that
say
be a good inference?
Yeah, well,
would it be a good inference or not?
Well, okay. Let me ask you this: who determines whether it's a good inference or not? Is that like a personal
there's no
thing?
authority for that. It's unfortunate that there's no authority.
Well, you guys tell us who are
it's very
authority.
fortunate that there's no authority for that, Ruhi.
Let me explain. Yeah, well, because if there was an authority, I'm pretty sure it would rule against upside down people and this tree in front of me that's rooted into the ground, moving at 70,000 miles an hour in an ellipsoid around a circle, right? So it would kind of conclude that, because I think that's ridiculous. All those things you believe, I think it's ridiculous, but that's just a personal opinion, you're free to believe them. But this is what's my whole point, right? You just believe. Like it's like how Spurs said, it's a religion.
No.
You just said it. You just said it. And then you just don't want to admit it. This is the problem. Yes. Yeah, you just, but you
yes, through here.
You just said you believe it all.
When you say I just believe, no, I don't just believe. I understand that people just like me go out and do these things.
For those things.
Yeah, and I understand that there were people just like me that wrote this Bible down and they wouldn't lie. I understand that. It's the exact same thing, brother.
You have a very different standard of evidence then.
Well, but remember, you're religious just like I am. So, I'll see you there. I'll see you at Hurley.
I can go out. I can go and measure the refractive index.
You can't measure the speed of light. You just admitted you can't do that. You measured delay.
No,
so why are you being? Now you're lying. Don't be a liar, Ruhif. Come on, don't be a liar.
What I think your point is that you're saying, we have to make a hypothesis and test the hypothesis. Is light moving? If it was moving, we would see this. We see this, and we can't therefore say that light is moving. We have to infer it. It's always tentative. It's always provisional.
Did I ever say hypothesis? Did I ever say that word?
I didn't say that you've had to.
You told me this is what I think you're saying, and then you said the word. Then you told me about hypothesis and all. No, I didn't say anything about that.
What I think you are talking
about.
Is
guess. Yeah, well, that's not what I'm talking about. I'm not talking about a guess. I don't want to guess. What I want to do is I want to see this object moving, because then I know it's true, right? Like I can time my drag car and I'm like, yo, it's at a quarter.
Do you know how retarded that sounds?
Maybe it's not light. Maybe it's not light moving then. Maybe there's a different mechanism.
Only Globers understand, and only Globers knows, everything. Yeah, it's retarded. Yeah, Ruhif. Yeah.
No, I've got to say something. There is actually. You can actually see light propagation. You can actually see light propagation. It's being recorded.
Guys, may I ask you something? And in advance, I apologize for my poor English. Is there any modern proof of R?
You can't prove anything.
Listen, I mean 20th century. Did you measure it?
The what, sorry?
R.
I
You're
can infer
ready?
R. I can show that my measurements are
I
consistent
don't
with a
understand.
given radius.
Did you measure
Hang
it?
on. I got to go and sort these kids out. Did I measure
Did you
R? I
measure
make
it?
calculations that are consistent with the radius being a certain number.
Calculations, yeah.
That
So
are
now
consistent. I got to go. Yep.
What's the
No,
number?
my
now
kids
you
are
sound
fighting.
now you sound retarded, mate. You are really retarded, mate. I'm asking about measurement.
With a measuring tape
Who's
or
next?
with math?
Who's next? Wait.
Measuring
Who's
tape
next?
or math?
Sorry, measuring.
Okay,
What
like
instrument can we use
like
to
Did you
measure
measure?
something?
I don't care. I don't care. Did you measure it?
yes, I did.
Okay, tell me.
Callie did.
No, tell me about it. How did you measure it? Hello?
I'm not saying I measured it. I'm saying what implement would you recommend to measure something the size of a planet?
Listen, I don't care what
I
you
know.
think about planet or whatever. If someone told me if someone told me that R is measured, it should be measured. Did you measure it?
I didn't measure it. No.
No. So you calculated, yeah?
I haven't calculated it now.
Okay. One thing.
He's being smart.
No, I'm not. I'm being honest.
You know what
Could
his point is.
Could you
No, I
just
don't.
be
Did
polite,
your
mate?
side measure it? Did anyone on your
The
belief?
the human race has probably calculated it and derived it, and we'll probably optically measured it from space.
Human
I don't
race.
know.
Human
I'm
race.
here.
Calculate.
Am I part of human race, mate?
Hello?
Am I?
Yeah,
Am I
yeah.
part?
I hope so. I hope so.
Yeah, I didn't measure it, and I didn't calculate it. So what you
No,
talking
luckily
about?
you're not the entire human race then, right?
Yeah, so I don't care. Listen,
But we measured it, and it
I've
wasn't a sphere. It was flat.
I've asked about modern proof of R measurement.
Well, first of all,
Is there any?
there's no such thing as proof of R. There's
Okay,
conclusion
measurement.
of R.
Listen, focus. Measurement.
Yeah, speak well first, and I would answer you.
Okay. Did you measure it?
Yes, I measure it.
Okay, tell me about it.
Yeah, before I tell you, there's two ways to measure things. If you have a box of wood, or
Listen.
a pyramid of wood.
Listen.
No, you listen because
just one
I know what
just
you're
one
going to say.
Can
I'm going to take 1 minute. You ask me a question now.
I
Let
know
me answer.
how to measure things. You know.
You can either put it
like
in
that,
water or you measure the dimensions. So there's math, okay? Because I don't want to hear anyone says this is math.
I'm talking about measurements, mate. Measurements. So you
get.
tell me, okay, I measured that tree, and then using some parallax, I've done it. Yeah, is it?
Yeah, something like that. And it came accurate.
Do you know what that mean? Do you know what that mean?
It means that
I'm laughing.
math
I'm laughing,
works.
mate. Yeah, because
you want me to measure it with a measure tape? That's stupid.
Okay. We're talking about geometric. How's that? Horizon. Yeah. So
no.
I'm talking about it.
No, I'm not talking about
it.
I didn't need it. You asked me. I'm telling you, I don't want the horizon.
Stop shouting, mate. Stop shouting. Chill out, okay? So I'm talking about geometric horizon. Is there any proof of measurements of geometric horizon, modern one? I mean, 20th century.
I don't care about the horizon in my measurement for the Earth's radius.
I'm asking. So if you don't know, shut up. Anyone?
I know more than you,
shut
and
up,
I didn't use the horizon.
Anyone?
You forced me to use the horizon. I didn't use it.
Modern measurements of geometric horizon. Anyone?
Now why are you running from me?
Listen, I don't wanna listen to you. Okay?
Yeah, because I don't use the trick that you want to play. You have a trick, and now I spoiled it for you. Sorry, I popped up your balloon. Sorry.
Okay. Next. Anyone?
I'll tell you what I've done, which is quite interesting. I cannot tell you the radius of the Earth. I really can't. But what I did do is I've taken 4 now, and it will soon to be 5. 5 observations. These observations range from about 5 kilometers to 20 I think the last one, the next one that I'm doing is 22.1. And what I do is I take the video or the images, and I get the angles and everything, and I do a geometric model based on that survey data of flat and then 1 degree curve over 69 miles. One of those so far has always matched the reality of the video, and one of them absolutely has not. I'll leave it at that. Suspense.
Yes, yes, sure. The only one model, it fits is, of course, what? Tell it.
Well, the 1 degree over 69 miles matches the reality perfectly. I wish it didn't, mate. I honestly wish it didn't.
It depends only on some stories,
You honestly
from
wish it didn't
ancient
match.
times.
Yeah, I really do, Paige. I really do.
Yeah.
Why?
Albiruni, measure it. Looking from
He
top of the
didn't
mountain.
measure it. He calculated it based on the refraction of R.
Exactly.
He measured a spot, said it was physical, derived his R value, created 7/6R, and then said the refraction causes the horizon to be in this position. So he's worked backwards. He backwards engineered it.
Exactly.
It's so obvious.
And Albiruni knew about it. Yeah, about his 5% from something he didn't see.
How can he be 5%? How can he be within 5% of a measurement they've never measured before? How did he know what measurement he was within 5% of? It's ludicrous, people.
Exactly. And they talking, that we sounds, retarded.
Yeah.
I've just proved that you regret the same
Prove
fallacy.
nothing. Shut up.
Yes,
How
sure, I
did
should
he
shut
measure
up.
a spot that moves with the weather?
I did
What
not measure
day
with the
did
horizon. I don't care about
Who are we
I'm
talking about now?
about Al-Biruni.
I don't care about him. I have my own
How?
method.
You don't care about. That's what it's come to. They don't care about any of their priests anymore.
I don't know.
Yeah, because we don't have priest Page.
Already. I
But
think
you do,
Page.
Ruhif. You really do.
I thought it was Page told you already that day by day the horizon it's moving. It's moving towards
just tell
you.
me, how did he pick the day? What did he do to pick the day to find the geometric horizon?
I don't know how accurate was his measurement.
If you don't know,
how could he be accurate when he hadn't measured it yet? How did he know what he was getting within accuracy too?
We don't.
That's so retarded.
You are retarded. Yes, you are retarded.
Just because you now reified that R value and say he was within 5% doesn't mean there was nothing there for him to be within 5% of. He just picked a day, went out, said, right, the horizon's that far away, that means the Earth is this big, and then he made his refractive index around that.
Yeah, I tried to point this out. Hold on real quick. I tried to point this out earlier.
It's so frustrating. You guys can't see this. It is absolute. I'm tearing my hair out here. Go, how can you see? He measured a physical position that changes with the weather.
Hello?
Sorry, Travis, go.
That's okay. Hold on real quick, please. Again, I just want, I know that we are like on
I gotta go.
on a
Sorry,
roll.
Travis. I gotta go. Catch us guys later.
It's okay. Yeah. Okay, so again,
All right,
I'm
see you
just
later,
going to,
Ruhif.
I'm just going to ask you guys to consider this possibility, okay? The thing that I challenged Ruhif to earlier with the ships that were on the ocean, and there was one that was moored, and then there was one that was in motion, right? My challenge was, where is the location of that horizon? Okay? You can't know that. You can't. You can measure the angle from your location, but you don't know the distance. So when Al-Biruni went out and did his astrolabe, all he could do is measure an angle. He doesn't know the distance. There's no way you could know the distance.
Exactly.
This is a story that we have been told. Al-Biruni is a legend.
Exactly.
Eratosthenes is a legend. These are stories.
Exactly. But these guys, will all, talking about that. Yeah. They calculated. They saw it. Yeah, I've done this. I've done this. No, you didn't do nothing at all, guys.
No,
Nothing.
what they did was they set out with a personal set of beliefs that nothing was created by a creator, therefore everything has to come from nature. So they built this whole story around that.
Okay, I've had a super chat here for you. Well, it's addressed to you, Paige. This is from Esteban Ilabaka, who says they figured out the accuracy years later with better measurements. How dumb can you be?
My point exactly.
Yeah.
So how did he get his R value?
The question to this guy is, do you know what conditions were, at that time when Al-Biruni was measured this?
Yeah, and so when they did it later, did they do the exact same conditions, or was it a different day? Was the weather a little bit different?
Yeah.
Like,
if you don't know,
Sorry. It's just retarded. This is so retarded. Like, we're arguing about the things that come after this story when the story is bullshit.
Let me throw this out there real quick, please, okay? Because I believe that what we can observe on low-level observations is going to occur on higher ones as well. The only problem is I haven't been able to get out and do that, but I don't think that it should be a problem to see similar effects. So I don't know, Crow XE, are you the one talking about this right now, or is there another baller here that's talking about Al-Biruni?
No, I didn't talk about Al-Biruni.
Okay, so who?
Al-Biruni.
Yeah, the guys.
No, we're talking about measuring the distance to the horizon, right?
I wasn't. No.
Okay, so someone, I felt like someone was advocating for being able to measure that distance. Okay, what if I could show you video capture of the horizon lowering from a higher degree to a lower degree? Wouldn't that change the angle of the observation?
Absolutely.
So that's gonna change your distance too.
Correct. Yes.
Right. I can show you that over a 26-minute period.
No, I've seen that, and I can find videos of that quite easily as well. Yes.
One more thing,
so
guys.
what did what did he decide was
Yeah.
then?
I honestly don't know. I don't look hundreds of years ago.
Oh my God.
I really don't.
Can you use your own brain and think about this? If it moves with the weather, how did he decide that was the position and that was the angle and therefore the Earth is this big? He couldn't.
If you're asking me to speculate, because I actually do not know, but if you're asking me to speculate, I would say he sampled it over. He probably made an observation that's pretty huge, as in the distances and angles pretty huge, not close to the water, but like hundreds of miles. And he probably did it multiple times. But I'm just guessing.
And you realize that all of this, right? You're right. You realize that all of this is hearsay and inadmissible because he has no idea.
No, I'm just saying. If you're asking me for my opinion, that was my opinion, Travis.
Right, but then it's irrelevant. It's irrelevant.
Yeah, and even if he did, yeah.
I won't give you my opinion then. If we can only talk in fact, this will be a very quiet conversation.
No.
Yeah, the Rumpus is fine to speak. He's not blocked at all. He can speak if he wants. I know he's been here for a while.
Well, I can't hear him.
Oh, wait a minute, Ranty. Quick question, Ranty. I did message. I sent you an email and I replied about your son's storyboard thing.
Oh right, okay. Yeah, I'll respond to that tomorrow then. I'll get back to you with that. Yeah, cool.
Okay, so what did we establish? That there is no modern measurement of R, is it?
Well, Esteban Alabanca has given another super chat. So he says that high elevation, less variable refraction. It's why you only do over water where it fluctuates and refraction is higher. Go up higher, it won't change that much. Therefore, standard refraction. So again, the going back to this
Refraction based on R.
Yeah.
That you got the R value from
Is there a
horizon that moves.
citation?
My
Is there a
God.
citation for that?
Jerking all the time, you know.
Yeah, circle jerk bullshit.
Refraction doesn't have to be based on R. Refraction, you get
refraction. Really?
Yeah.
Did you?
That's what I was saying before, that we could just apply it to a flat plane.
No, absolutely. On a flat plane and on a curve, independent to the surface of the Earth, you can have refraction.
Did you provide measurements of temperature gradients meter by meter? You know, from that object you're observing to you. Did you provide it?
Which object?
Sorry.
Which object?
Horizon.
You want me to?
The horizon's not an object, is it?
Yeah. Wait a minute. What are you on about?
So what did you observe?
I think we're in a different conversation here, mate. Sorry.
No.
Yeah. I didn't mention object or horizon.
I'm talking about object.
So
what did you?
Object you're on about?
What did you see there? What did you point? What did you point there that you think, you know, that I need to measure, you know, until this point? What did you see there?
I still don't know what you're on about. I'm sorry.
Okay, sure, yeah.
They think they saw the horizon, a physical edge to the ball.
Exactly page. So
absolutely no. I can agree to that. I see. Wait a minute. I can agree. You said something I can agree to.
Wait. What did you see?
What did you see? You've said something that I can agree to. I agree. I see a physical edge. It is normally water.
You don't have a physical edge anymore. Black Swan. It moves with the weather.
The Black Swan has physicality to it as well. But I see a physical object in front of objects that go behind. Yes, it is physical. It is water. Water is physical to me.
Water.
Sorry.
We're not talking about water. We're talking about the horizon.
Yeah. I'm saying
a position that moves with the weather. It's not.
No, that's fine. It moves, but it's physical. It's water. Yes.
Okay, all right. Okay, if you want to call it physical because it's water, how do you measure? How do you decide which physical geometric horizon you're measuring, depending on what the weather is that day?
I don't measure the horizon. I've already said.
Which point did you?
Me.
Which point did you? How is that in English? Sorry about that.
No, you're all right.
Marked. Which point did you marked on your picture or something that you're talking about? That yes, this is the physical edge of Earth. I mean water. You said, yeah.
Yeah, water. Physical water.
Yeah. Which point? Could you show us on the picture? Because I call it bollocks, mate.
Oh, nice.
I show one guy, the bunker. You know, this is the Polish debunker who analyzed the picture, and then he choose pixels on that picture. You know that. Oh, I think it's there. So you're talking about this thing, yeah?
Yeah,
you guess.
It's an arbitrary measurement.
No.
Just guess.
No.
Show us. Show me now.
Give me a second. Give me 2 seconds.
Well, whilst he's checking that out, can we just do a quick mic check with Rakia Life? How's it going there, mate? So we can do your levels.
Yeah, doing great, Randy. Thanks.
Okay, good stuff.
What about my mic check, Randy?
Yeah, I'm just working on that first. I'm working on that. Right, here we go. And Ali B.
How you did?
Yeah,
shout out to Ali B.
Your mic's actually done. Your mic's actually already been done from last time, so it's all good.
Oh, nice one. I want to school Stingray again. It's becoming a habit here, but I suppose.
Go on then, Ali.
We've all got a job to do. There is a hump of water. It is called the Sagitta. You should know that.
No, I don't. No, I don't.
Oh, okay. Well, that's the hump of water that's in between you. You had a conversation there. If I was standing,
see, I wouldn't call it a hump.
It is a hump.
Well,
it is a hump.
You might describe it as that, but I wouldn't call it that. So.
No, but that's what it is. That's what water at the top is. A big hump in front of you, 20 miles away from me. There's a big hump of water there.
Yeah, I think. Yeah, I wouldn't.
The Sagitta. It's called the Sagittarius. That's all.
Yeah,
I don't
that's
want
cool.
a conversation.
Well, Mick West,
All right.
Mick West used to have it in his calculator. In fact, he used to call it the hump.
Yeah.
I just wouldn't, because to me, but this is just me again and just my opinion. A hump to me says that something comes up.
It does. It is, because the fact is, well, wait a minute, listen. If I'm standing 20 miles away from you, there's a big drop there, right? So if you draw a straight line from my feet to your feet, there's a big, huge hump in front of us.
Yeah, but to me, a hump goes up. That would only ever be dropping away.
No, it doesn't. How would
Well,
it
would
drop
to me.
away?
On
Well,
a,
it wouldn't,
on a
because
planet, it would. But yeah,
you'd be looking
but
up.
that's just me.
You'd be
You
looking
can
up
call
the
it whatever
road,
you want.
yeah.
I just never call it a hump.
Great.
No, but it's
You
called
found
that. But that's,
Yeah,
that's
I'm
the
just waiting.
scientific.
I'm going to
That's the
share.
scientific
Wait
term.
a minute, just 2 seconds.
That's the scientific term for it.
All right, I didn't know that.
He doesn't call it
Am I
because
all
it
right
sounds
to?
silly.
Am I
Because it
all right
is
to?
silly.
Okay.
Yeah,
Am I
you're all
right
right to share. Yeah.
Can I just ask a question before he does that?
Yeah, you can still share. You can still share your screen.
You made a,
Yeah,
you
that's
made
fair.
a statement. I just want to ask you a question. So you said that you wouldn't call it a hump. You would say that it's going down away from you. Is that what you said?
Yeah, no, but this is just my opinion. I wouldn't call it a hump.
Okay, but you used the term. You consider it. In what direction do you consider that sphere to be going? Like Ali said, 20 miles away from you, right?
So
if
that
Ali's
that would be a gradual curve descending away from me.
okay, so Ali's 20 miles away from you. Are you descending away from him too?
From his relative point, I'm descending away from him. From my relative point, he's descended away from me.
Why is there no ascension?
Because we're all on the same elevation.
Yeah, we're
it's
all
just
level.
Yeah,
right, that's
it's
right.
just it's just relative to an individual. So yeah, just really quickly. So you asked me for my examples.
If you assume you're on a ball.
So, wait a minute. I'll tell you what. Let me just get through these two examples, and I'm happy to do it with any other. And I've been asking any other visual examples. I will model it both flat and curved and see what matches, and I will be absolutely open about it. So here are
Are
two.
you going to model it on a flat plane with 6/7R or 7/6R?
No, because that wouldn't be a flat plane, would it? So
no, it wouldn't, would it?
So no, it wouldn't. So here we have a guy. Someone sent me this on Jose's. Here we have a guy who's on holiday and is running out and is viewing this. Now at the moment he's on the second story up from the beach, which is about 8 foot high. The beach is about 8 foot high at the top, and then you've got 2 stories on top of this that he's at right now. What he does is he runs all the way down. Sorry, wait a minute. He's going. He's now at the first floor, and then he manages to go all the way down and get down to the beach, and then goes and has a look at this. And then he does the reverse. So he's come down here and he's seeing this. He does the reverse, runs all the way back up, and we can actually track his elevation on these steps going up to the second thing, and then eventually ends up on the third, which is where he was when we first saw him, which is there. Now, what I can do is I can take this observation and I can think, right, well, looking out over the horizon on a geometric curve that's 1 degree over 69 miles, I can have my camera do the same thing to this object here, where he's running along and the camera's raising to the third floor. And then when he goes back down to the ocean, we get that. And then the second thing that I do, and let me finish this, and because again, I will do this for Flat Earth in support of Flat Earth if anybody gives me observations to do this.
I just want to ask one question.
Wait a minute. Let me just. Please let me just get through this.
Just let him finish, please.
There was a mirage right there.
Hang on, hold on, please. Just let him finish. Just let him finish, please.
So another thing that I did here is, and this one was more accurate. The other one was an ad hoc thing that I did on the fly, but this one was actually accurate because this is the Viking ferry, and I went away and got the survey data for it, and you can identify it because it's got this cool little round window, and I managed to find it on the Viking line. So we see it here, and I know its length, and this was a Nikon B950. I've got the data. It's actually on the YouTube information where I got this video from anyway that someone sent me. So I know the length of the boat and I know the field of view. So I can actually work out approximately, give or take, let's say 5%, how far away this boat is because I know the field of view of the camera and I know the size of the boat.
Sorry that I disturb you.
Just let me finish. I'm nearly done. Just
please let him finish. Please let him finish.
Just give me 2 seconds, because I have actually got to go in a second. I've got a computer that's playing up that I've got to fix. So it comes up here, and I see it approach the port. I guess it's going to. We don't see much past that point. The camera's a little bit shaky. So what I did then is I went and I got the Viking boat. That I modelled the size of it, which is actually quite a crap model, but sod it, so be it. And this is the size of it and approximately where it is, and we can see that it's down, but we can actually go over here and see that it's actually sat in the water fine. It's just that this water is curving 1 degree over.
We're not
69.
seeing anything there. Well, you're not sharing what we need to see.
No, your screen is cut off somehow.
Exactly.
Oh shit! Oh,
we cannot see it properly. That's why you know.
What about is that? Can you see it there?
No.
It's just the patches, you know. That's it.
Oh crap! Okay,
maybe,
wait a minute. I'll try and I'll try and reshare.
Okay. What would you say then, Travis, if I was to say that I did the same thing as this, and I got perfectly flat over a distance of 20 miles? What would you say to that?
So I guess I would want to look and see what you're looking at. What do you mean perfectly flat? So did you have a similar effect?
Not really. No, when I was higher up, you saw all the buildings, and when I went down very low, down to about a foot, you saw all the buildings.
I think you need to stop sharing him and then start again, you know, because
I've got a clear shot. I can see what Dean's doing.
Okay, cool.
That would be refraction, Ranty.
Yeah, that would be right, exactly. But see, listen, guys, listen, please, Ranty. I know this. I'm preaching to the choir, and I know Allie too, and anybody else who listen. These days are so dynamic and diverse that each one is the result of refraction. I know that Ranty and I are going to disagree on shoaling. I don't deny that shoaling exists. I think that it is probably harder to prove in these instances. And I'm going to default to refraction 100% of the time. So the way that I say it is the complete opposite. I'm inverting the heliocentric model. When there is high extreme refraction, in the way that they say extreme refraction, you have limited visibility. When you have extreme refraction in the opposite direction, and listen to me, they're both extreme, people, because they're both giving you refraction, even though you don't have a classification for it. But when there's refraction that's extreme in the opposite direction, that obstruction that limited your vision in the first case has now disappeared, and now you can see farther. But it's always the result of refraction. It always is.
Another thing is that I think even if we will talk about it, 10, 20 years, we don't get to the point, I think, because there is not possible to prove flat or ball, even through observation, ocean or boat on the ocean. That's not possible, I think, because water is always moving. So we need to ask.
I have it.
Wait. We need to ask bowlers, about Deere's proof and how they did done it, and then we need to make it, by ourselves and check it. Otherwise, we never get how is that a right proof. I don't know if I sounds sorry about my poor English, but probably you understand what I'm talking about it.
Do you have a link to this video, please, so that I can have a quick gander at it?
Yeah, I mean,
yeah. I'll find it for you now.
Dean, listen. Your 3D image is missing refraction. Those boats are compressed. Your image is not compressed. Your image is to scale and hiding behind something that you can manufacture on your computer. When you first started that second shot with the cruise liner, there was a mirage at the base, bro. There was a mirage.
kind of simulation. You know, it's really ridiculous.
Secondly, the first video that you showed, when he went down lower, I've made these observations. I recognize right away the characteristic of that water is that it is being refracted up apparently higher. It looks like he's close down to it and the close down and he's near the water. He's not, but that's the way the refraction is presenting that image. I have hundreds of these. I put them up. You guys ignore them. You do not consider the alternative. I have given you a logical, sensible, and empirically supported alternative, and no one is paying attention. And yet, here I am talking to you again.
Yeah, well, can I just say something? The reason I asked for the latitude is because that equation would only really work, you know, that 7/6R or whatever, or the 8 inches per mile square would only work at the equator, because if you that 60 miles is 1 degree, because when you get to 47 degrees, which is about New York or something like that, the latitude, your 1 degrees only cover, you get that after 52 miles because of the oblateness, or it goes thinner at the top. So it's actually 52 miles. That's why I was asking Stingray what latitude he was doing it at, because the higher up you go, the closer that 1 degrees becomes. You know, after they say 69 miles. 69 miles is 1 degree, but that's only at the equator. That's only with that circumference. But if you go up to the higher latitudes or the lower latitudes, 47 degrees, say New York, that 1 degrees is after 52 miles. So they seem to forget this. They seem to use that as the overall equation, but the Earth gets thinner along the latitude lines as you go higher. So that 1 degrees, 60 mile things it's like a fallacy kind of thing, you know. It only work in one place, which would be the equator. So you should really, when you're doing your measurements and your calculations, when you're higher up, you shouldn't be using that equation. You should be using another equation, meaning that there would be more missing off the boat.
I really appreciate. Appreciate you try
now
to.
I need to comment about this
Can
because
I?
this is wrong. I'm sorry, Ali. The 1 degree is a 1 degree of the 360 degrees of a circle.
Dude, no, it's not wrong.
Matter.
It's not wrong, because I've read a paper about it, and that's what it is. This doesn't come off a flat
I understand you. I understand
It's
you.
a fact. So
You are
after
talking about
52 miles, dude, after 52 miles, it's 1
I
degree.
heard everything you said. No need to
Yes,
repeat
so
it.
what you arguing about?
I'm not arguing about what you said. The distance between the longitude line varies, as you said. That's very true. But
Ali,
of course,
the angle.
just wait. They just wait, you know, for arguing with them. You know, they just wait for them. I agree with Nathan. Don't allow them to beg the question. You know, just cut it off. Just cut it off, and then you will see it's really much easier and simple. You know, simple discussion with them. You know,
well,
No, I'm sorry.
I'm a little bit torn.
Alibi was talking about the globe and
Okay,
why the globe
Yeah,
is
but
not
I'm-
correct.
no, but,
So I have to talk about the globe and say why it is correct.
Roxy, listen. Yes, I'm talking about it. You know what globe? Which globe? Did you prove it?
Yeah, but
Then
wait a minute. Can I just say something? I kind of
Okay,
half agree.
go ahead, Alibi.
Whoa. I kind of half agree with you. Is that Level World that was talking? Yeah. Who was it that was talking there? About the cutting off. I don't think you should. You know, I'm kind of torn between that, because sometimes it's good to let them talk, let them hang themselves. But I agree also sometimes it's good to cut them off as well and sort of correct them. But as I say, there isn't really. It's all dependent. But I don't agree with Nathan Oakley that he just cuts them off straight away, because sometimes they reveal more if they talk. But as I say, I have problems with that as well. I like to cut them off as well.
Well,
I think sometimes
agree.
it's detrimental. 1 second. Sometimes it's detrimental to cut them off, and sometimes it's better to let them talk, let them finish their little story, and then rip it to pieces.
Guys,
But
just
as I
really
say,
quickly, Just really quickly, guys, because I've got to get off now. Ranty, I posted that link in your general chat. I didn't know where to put it. But
the problem is not going up and down the stairs on that video. But
oh shit! Oh no! Sorry, I thought you meant. Sorry, I thought you meant the second one that I showed.
But that's fine. That's fine. I mean, yes, if you can find the other one as well, that'd be great. But on that video that you sent me, I mean, it's just compression. There's nothing missing on the boat. I mean, I don't know what you're seeing on that particular video, but
that round window is missing. You don't see any compression of that round window.
The round window, okay.
Yeah, so on the side of the distinctive thing about that Viking thing, which allowed me to find it on Vessel Finder, is it's got this huge round, like 40-foot window on the side, which is like this dot that you can see. When it gets close up, you'll see it. And you'll see it when it comes over the curve. You get to see the window.
It doesn't go over the curve.
Well, you know, we'll agree to differ there. But what I would ask, and the offer's out to everybody that is on your channel as well. Get me some observations where I can plot the geometry of the situation to see which it better matches 1 degree over 69 miles of curvature or flat. And then and then I'll do both. In all fairness, and we'll see which one it matches, and that'd be cool.
Geometry includes.
I've got to go now anyway.
Yeah, refraction.
Thank you.
You're talking about?
No, we'll leave refraction out of it. We'll just see which matches without refraction.
Yeah, matches. Yeah,
Refraction.
I know
severe refraction will only affect probably 1 degree over 69 miles, and that's to your black swan.
Listen,
most of the time it
I
won't.
I know a Polish guy who is making better simulations than you. But
that cuts me really deep. This isn't my job though, so I'm all right with
he's
that.
also, yeah, you are. So he's also Glober, and he's how's that? He thinks that is the most educated guy in the world, but he's not. So okay, guys, sorry about that. I really appreciate that I could be a part of this conversation. Randy, thank you very much. I wish you all the best. Hopefully we will get better soon as possible. And guys, don't stop it, because that's a very important thing. These people lying just into our faces. So don't give them even 1 millimeter of ground. That's it. Thank you very much. Thank you.
I have a question. I have a question. Is saying the Earth is flat without evidence begging the question?
Sorry, which begging?
I think it is, isn't it?
That's begging the question against begging the question. That's it, mate.
Right.
Do you understand?
We don't say it's flat. We're asking for proof of your claim.
That the Earth is flat.
No, we don't. We're asking for proof of the ball.
Evidence to the contrary. You beg the question.
No, you don't have any evidence. That's our point. You think you do, but you don't.
Please stop. It's a logical fallacy. Please stop.
Well, it's not actually. I've got evidence. I've got evidence. I've got evidence of the flat Earth, Sean. Sean, I've got evidence of the flat Earth.
Present it. You haven't presented any evidence so far, so present it now.
Go and look in it. Yes, I did. Yes, I did. Go and look into attitude indicators on an aeroplane. That's it. End of story, my friend.
That airplanes fly a level course with the curvature of Earth's waters.
No, they don't. No, they don't. You don't understand.
Fuck
wait a minute. Whoa. You don't understand what an attitude indicator, dude. Sean, you don't understand what an attitude indicator does. You haven't got a clue.
Do you know what the adjective of level is?
2 years ago.
What's that got to do with? Wait a minute. What's that got to do with an attitude indicator, Sean? Sean, you asked me for evidence. Sean, you asked me for evidence.
Curvature of Earth's waters. That's what the adjective of level is.
No, the attitude indicator. Wait a minute. Let me finish.
I've listened to everything you have to say, man. You're speaking.
I wasn't talking to you. It was someone that was interrupting. You'd stop talking. All I was saying was an attitude indicator clearly indicates that the airplane is flying over a level fucking plane. End of story.
No, over a level Earth. The fiber optic gyro and laser gyro prove
the laser optic gyro. The laser optic gyro is not. The laser optic. Excuse me. Stop going on to your fucking stupid. That's what would you expect?
Don't fucking call me stupid,
listen, right, wait a minute.
Fuck
Here-
you, Allie B.
here's-
Don't fucking
here's
abuse
the
me,
easy.
asshole. Fuck
Here's
off.
the easy one. Here's the
Ooh,
easy
got
one.
someone
So,
triggered.
wait a
Fuck
minute.
off.
Whoa.
I
Right.
need
So
to
there's
take
a
a shit,
light.
moron.
Listen, there's
The
a light
angles
on
of
top of a
Polaris move-
high-rise building, right?
The angles
Sean,
of
let me
Polaris-
come on, man.
angles to Polaris
Come on, Sean. Let me
debunk the
finish.
flat
Don't-
Earth. They're impossible.
Sean, you've been doing
That
really well.
geometry is impossible. So until
Sean,
you
you've
can
been
prove
doing
that it
really.
is,
Sean,
yeah, piss
Yeah,
Sean, you've
Trent.
been doing really well
Yeah,
the last
let's-
few months.
do you have any mental disabilities, mate? Do you have any mental disabilities?
Right, let's hold on. Nobody, none of this.
shut up,
Hold on.
okay?
No name calling, please. Right? You know, we've had a great
that's
conversation up to now. You know, we've been going
Yeah,
for over a couple of hours. So please,
Shut up.
please, just one at a time, and try and make your points.
Can I address him, Randy?
Yes.
Can I address
So
Sean?
I have a
I give a
challenge.
scenario.
I have the angles to Polaris challenge. Take the challenge.
Right,
and we'll
I'll. Can I explain it then? You've done that. Don't interrupt me, right? Right. Okay. So here we go. I'll give you a scenario. We're looking at a big high-rise flat, right? There's a light on top of that high-rise flat. We measure the angle from a mile, right? And we take the angular size of it. Wait a minute. We take the angular size and we look at that light and we check that light. Now, if I move away 20 miles, that light will appear lower in the sky, right, due to perspective, as I walk further away. So there you go.
Yeah.
So if I look up at Polaris, a star in the sky, move further away, it's going to get lower in the sky, isn't it, due to perspective?
Right.
There's
By
your,
1
there's your
degree
answer.
by 1 degree per 69 miles walking away.
Yeah, well, there you go then.
from
That's, yeah, but
Polaris.
how does that prove it's a
That
ball?
geometry is impossible on a flat Earth.
No, it's
I've
not.
proven it.
How is it?
Oh, yes, it is. Absolutely. Yeah,
How is it?
absolutely. I've proven
That
it
light,
4
the
different
proof
ways.
is that light will go further down,
3
though.
different videos.
Ali,
But that light will
see?
go further down, yeah? It'll go down lower
Yeah,
in the sky
yeah.
the further I move away. So
Right.
what are you talking about? And as I get
Because
closer,
of
it'll get higher in the
perspective and
sky.
because of curvature of the Earth, both. Yeah.
No,
Absolutely.
but it's the same thing, Sean.
But
It's the
if
same thing. If
something
I
is
get further away from
3,000
an
miles
object,
over your
the
head,
top of that
it
will
could
get
never-
lower.
Ali,
If
see
something is
now?
3,000 miles over your head,
You
it
can't
could
see
never
past
drop
it.
below
You can't
20
see past
degrees
that.
above the horizon, ever.
But that's that. But,
Can I now? Speak
yeah,
now?
go for it. I'll mute because obviously it's.
Go for it.
Sorry, Ali. Look, see now. Look,
Look,
I'm really
look at what?
support. Sean, could you just wait for a minute? I'm gonna say something.
Go
Okay,
ahead.
Ali. See now. I told you sometimes we need to cut it off. I agree with you. That sometimes you can
Are you
allow them.
talking to me or Allie?
Shut up, Sean. Okay.
I thought you were
Just
addressing me.
just
Why are you talking to
let me
Allie?
speak for 1 minute. 1 minute. Okay. Thank you.
Well, address me if you're going to talk to me. Don't
Wait.
talk to Allie.
Okay, I will. Now I speak to Ali B. Okay. Do you understand
Okay.
it? Thank you, Ali. Quantum Eraser said something like that.
Quantum
we-
Eraser's a joke, dude.
So
He's a
listen. I'm talking to
He's a
Ali B. Do you have
quantum.
some
You're going to bring him into a
Sean?
scientific
Sean, do you
discussion?
have some mental issues?
Come on,
I
Sean.
think you
Let's
do.
keep it civil
No,
here. Come
no,
on, mate.
no.
You've been really
Guys-
well, Sean. You've been
Guys,
really
the
good. The last few months, you've been very, very
Yeah,
calm,
they have to
collected,
act childish at some
and I
stage.
was complimenting you on it.
Disturbed
That's
after a
good.
couple seconds. Just
I've-
wait. Be
I've
patient.
proven QE. I've
Okay,
proven
you
that every
prove
one of
you. Okay.
QE's
Listen, I'm
citations
talking
prove
to
him wrong.
Ali. I'm talking to Ali.
So-
Could you just wait for a second? Thank you, Ali. Quantum Eraser said something like that we need to prove from bowlers that they standing, in the on the how is that North Pole, looking, directing up, to see Polaris, and then from this couple measurement. This is this is what I remember, but that's not exact what he said, but you know what I
I
mean.
get.
Yeah, you know what
So
you
it's a
did. Yeah.
genetic fallacy.
Shut up.
Yeah, I
Sean.
get. I totally
Yeah,
get what you mean.
Genetic fallacy is what you're
Ali,
talking
you
about.
understand it until they show it.
Yeah.
We cannot do anything, and they are fucked.
No,
They're
that's a
fucked
genetic fallacy.
because they never
I can
saw.
refer to
They never
measurements
saw,
that have already
and they
been
never
taken.
show to us. They never
I
show
can-
to us.
I can
Yeah,
refer to
Sean,
measurements that have
You
already
can.
been
Yeah,
taken.
you can.
That's true.
You
by
have measurements of
astronomers
your
all over the
what?
world.
Of your what?
All over the world. Astronomers
All
all
over the world. You
have
have
to
measurement.
say-
Yes.
Now you're going to
yes,
let me talk, right?
Yes.
Astronomers
I
from all over
can't
the
because
world.
No, I
because
would
you are
not
deranged,
let
mate.
him
All
go.
You are
over the world,
deranged.
astronomers have to
You are
set their
deranged.
telescope
You have
to the
mental
angle
issues for sure.
of the latitude that they're at.
Yeah.
Astronomers have to set their telescope to the angle of the latitude that they're at. I'm at 39.449. I have to set my
Doesn't latitude assume a ball?
39.4.
Yeah, exactly that page. They're just assuming a ball on it.
For it to be pointing at
It
the
means
Polaris.
nothing.
Now, if I
It means
walk
nothing.
It really,
I know, I know.
means nothing.
that angle will change
But they
by
think
1
it
degree.
does. That's the
It will now
funny
be
thing.
I know. It is. It's amazing.
And if I walk another 39 or 69
Right, one at a
miles
time,
down,
please.
the angle will drop another degree. Now, should I repeat myself, or are you going to talk over me again?
Yeah, but so
you don't
what,
want to know
Sean?
the truth.
You've
You don't
never
want to
been
know
on.
the
You've
truth,
never
do you?
been
So you talk
Norfolk.
over everybody who
You've
tries
never
to tell
been
you.
on Norfolk, mate. Never been.
I got nothing to.
Never
I got
been
nothing to hear from you, dude. If you're not
Hey,
going to let
Allie?
me talk, fuck off.
Hey, Sean, can I just say something to Allie here?
Sure,
Hey,
Jordan.
Allie, what you said regarding the angle to Polaris on the flat Earth versus a globe Earth is correct. I mean, as you move away from the pole star, it will appear. Will you
George.
shut up?
George, no.
Let
Let
George
George,
shut up,
let
man.
George
Let me
talk.
speak.
Let him talk.
Can you
He's
show?
agreeing with us. Are you going to interrupt people that agree with us as well? Is that what Quantum Eraser does? The guy's agreeing. He's going to make a point. Let him make his fucking point, man.
Exactly what Quantum Eraser does. Quantum Eraser doesn't have a position, so he has to yell at people.
Right,
and
George,
talk
on
over
you
them
go,
and
mate.
use them.
On you go. Go.
Yeah.
Come
But
on,
I agreed
give
with him,
George a
George.
chance. On you go.
I agreed with him that the Polaris will drop due to perspective, but the amount that it drops on the horizon is inconsistent with reality on a flat Earth.
Sean, can you?
It's true.
So how do you know what reality on a flat Earth is?
Because I've mapped it out. I've charted it and I've modeled it in 3D.
Really? You've modeled it based on a ball, based on latitudes.
Let me talk. I've created a model, physical model, that I modeled flat first, and it didn't work. The angles didn't work when it was flat.
Because
so
you're
I've made it
using the
clear.
angles you're assuming from a
I modeled
ball.
it 4 different ways. Okay? It doesn't work on a flat Earth. I know this. I confirmed this. And you can keep talking over me, Level World, and you can be a fucking hypocrite. So, or you can shut up, okay, and let me talk. I've modeled it 4 different ways in 3D on a computer, in a physical 3-dimensional model with my hands and an X-Acto blade and a glue gun. I've modeled it 2 different ways on paper, and it does not work on a flat Earth. The geometry is impossible.
Models are not reality.
And what geometry are you using?
I'm using the angles to Polaris based on my latitude.
Exactly! Based
Now
on
you
a
model
ball.
it has to prove to me it will work on a flat Earth, and I'll take it seriously.
Yes, effective.
Hold on, Sean. Hold on, everyone. There's a big
No, it
problem
doesn't.
here.
The
Hold on,
angles
sorry.
do
There's a
not
big
match
problem.
up
We
with
don't
the amount
understand
of
each other.
distance you are from the North Pole. It does
Hold
not
on,
work on a
Sean.
flat Earth.
Sean, please, everyone. I want to say just one thing. There is, I think, there is a doubt that the angles to Polaris doesn't match the latitude line.
Right.
That's it.
Exactly. Not on a flat Earth. It only will on a curved Earth. And when I made my physical model, I did it flat. I didn't presuppose the globe. I presupposed it flat. And the angles did not work. None of the
You
angles
didn't
pointed to
presuppose the
same
globe,
place
but
in
you
space.
used
Shut up,
latitudes.
Dave. None of the angles
I'm just
pointed to
asking.
the
Did you
same place
say?
in space until I wrapped it around a curve, and then it did. And I'm going to keep.
No, you wrap it around a curve and then say it can't work.
Over me. Now you're going to continue.
Don't you see you do everything backwards?
Or you don't want me to keep talking?
Okay, right. Listen.
The only way it would work is if I wrapped it around a curve.
Stop into page, shut up, because it's really rude.
Right, let's
You're gonna talk over me.
Hold on. Right, okay. So this is sort of it's going downhill because people keep over talking one another. Can you just let people finish their explanations and then ask your question? And let's do it in that order, please. And all this shouting over isn't really helping matters, really.
I agree.
Right. Okay. So you say you've done this modelling. Paige, have you got something you want to ask about this modelling that Sean did?
Yeah, I just wanted to know whether he did his modelling on a flat plane using latitudes.
Yes, I did.
Well, there you go.
And I used the known angles to Polaris, matching the latitude of the observer, which is
our argument is perspective will give you those same.
Not up for argument.
Can I respond? Our argument is that perspective will give you the same angles. You don't need to stick yourself on a ball.
Then you have to explain to me how parallel lines can cross, because Polaris on a flat Earth, when you're standing at the equator, Polaris would be at 6 feet above the off the ground. Now parallel lines don't cross, so that means everywhere you go on that flat plane page, you're talking over me. Everywhere you go on that flat plane, it means Polaris is going to be at 6 feet. Now, where is Polaris 6 feet off the ground?
It'd be 6 feet above the horizon, shot 6 feet off the ground, my friend.
If you're 6 feet tall, that would be
not actual position.
That would mean it has to be at 6 feet off the ground.
What angle would it be, Sean? What angle would it be, Sean? Sean, what angle would it be?
What on a flat Earth, if Polaris was 6 feet off the ground,
Mm-hmm.
or at eye level with you, if you're seeing it at the horizon, it would be at a 0 degree angle. It would be straight forward.
So you don't think that there would be any obstructions in the way to your to your viewing of that object?
Not if you're on the water, not if you're on the ocean, no.
You don't think that the ocean moves?
No, not enough to obstruct something that's 3,000 miles over your head. It can only go 3,000 to 4,000 miles away from you. That's a 45 to 30 degree angle, man.
Okay.
How does it get lower than that?
You don't think that there's obstructions in the way with visibility?
No.
No. So you're ignoring reality then?
No, I am showing you reality. I'm presenting you with reality. Because anywhere you go, north or south of the equator, any telescope you see that's set up, an equatorial telescope that's set up to rotate on the polar axis of the Earth, will be set at the latitude of that viewer, of that telescope. If that telescope is at 45 degrees south latitude, it's going to be pointing up at 45 degrees. If it is 37 degrees north latitude, it's going to be pointing up at 37 degrees. This is incontrovertible. This is not up for argument.
All right. All right, Sean. How on a ball Earth could anybody in York, England, see the Southern Crux?
In England?
Yep, from York.
I don't know.
Documented. No, tell me how could that be possible on a ball Earth to see the Southern Crux from York in England?
You
documented.
Can see the Southern Cross from York?
It's been documented in the 1800s.
Can you see it from York? Show me a photograph.
It's been documented. It's been documented in the 1800s.
Take a picture of it from York, England. Tonight.
You could see the Southern Cross.
Prove it.
You could see the Southern Cross from York.
Take the known angles to Polaris.
I'll get the book. This was done with scientists. It was accepted. It's accepted. It was an accepted fact. They've seen the Southern Cross from York. I'm not sure you're
Why standard do you hold us to?
I don't believe in photographs. Hey, dude, photographs prove nothing. Sean, that's one thing I never asked for is a photograph. Photographs prove nothing.
Well, you seem to think that they proved that the Earth is flat with a black swan.
I never said. I never mentioned. Photographs prove the Earth is flat. I told you gyroscopes, dude.
Well, that's what the whole premise of the black swan is.
That's all I need, dude.
That's all I need. Physically change the shape of a measured planet. That's the premise of the black swan, right? That there's a magic camera that can change the measured shape of a fucking sphere.
Who said that?
No, the premise of the black swan is that your horizon is not physical, therefore cannot be measured as a certain spot that you can derive an R value from.
The geometric horizon.
Yeah, but photographs don't prove anything. They're susceptible to optical.
Can change. Refractive conditions can change, but tangency does not. Okay.
So if refractive conditions can change, why do you pick one particular day to get your R value? What if I went out on a completely different... Yeah, exactly. What if I went out on a completely different day and the horizon was way further away? And then I made your R value from that.
Who says that we get the R value of the planet
Al
from standing on the
Biruni.
seashore looking at the ocean? Who says that?
Al
Who does that?
Biruni.
Who has
Your
ever measured
priest.
the radius of the Earth by standing on the seashore looking at a refracted horizon? Who says that?
Yeah, that's Paige, sorry, just a minute. That's
top of a
wait a minute, Sean. Let me talk to Paige just for a second. Paige, that's
where there was very little refraction. That's what
Sean,
Alberuni
one
did. You
second,
don't know
one
what
second.
Alberuni
Paige,
did. That's your
he's
Paige,
so
that's
triggered.
stupid. Wait a minute.
No,
That's
I'm
stupid to think. It's almost as stupid to think that you can measure the
stupid,
radius of
isn't
an
it?
Earth
That you can measure
with
from
two
a
sticks.
position that moves.
No, with two
you
sticks.
can measure the shadow.
Okay, one at a time, guys. One at a time. One at a time. One at a time, guys. Please, right? Okay, so Ali B.
Sean's not giving
Hold
us a
on,
chance.
hold on.
Sean's not giving us a chance.
Okay,
He's just
okay. Listen. So Ali B had something to. Sean, just a minute. Ali B. Sean, just a minute. Ali B had something to say to Paige. If you could just repeat that, please.
Yeah, Paige, that's ridiculous to think that, because it's almost as ridiculous to think that two sticks in the ground could possibly show the circumference.
Yeah, I'm so stupid to think somebody could measure a physical position from a position that moves.
I didn't mean that as an insult.
Trigonometry is so stupid, isn't it? Trigonometry.
All right, carry on.
Yeah, when the position moves, it is. Absolutely. To assert that you've got a geometric horizon from somewhere that fucking moves. You moron. Like, honestly.
He measured to the geometric horizon page. He measured to the horizon, the one we can see.
Exactly. Welcome to flat Earth.
Definitely prove that the Earth isn't flat.
Oh, even though your priests say if you use a smaller, closer sun, it will give you a flat plane. Right.
Yeah, when we talk about the horizon, they default back to the sun and stars every time.
Shout out Brian
like
Leakey.
But the numbers won't match. It will not match up with reality. The geometry of it will not match reality.
No, it just doesn't match your religious belief.
No, the reality is that for every 69 miles,
the reality is the horizon moves, therefore you cannot get a geometric position.
Polaris drops 1 degree in our view.
Perspective.
Fact.
Sean, why couldn't you get your telescope to do that? Why couldn't you get your equatorial mount to work if it's so perfect, Sean?
Because the software was faulty. I had to upgrade it and I had to fix it. That's why.
Whatever. You said you're getting rid of it. I can't get it to work. I'm getting rid of it. Okay.
Right, to get one that works, moron.
Okay, why is perspective not used in that calculation?
Man. You bring nothing to the table.
Dude, you're a known liar,
okay,
dude.
Listen, don't argue with each other, right? Listen, I meant no ad homs, right? Listen, Sean, I have a question for you, right? So, obviously, when we view things in the distance, there are many occasions when we see things missing from that particular object, whatever it is, a tree, building, doesn't really matter. We see that we cannot see parts of that. In your model, you assume that because we can't see some of it, it must be a globe, and that's it. That ends there for you. That's you. Literally, it's game over. That's what you all say. If you can't see it, it's behind the curve. It's a globe. Whereas you don't take into account. You don't take into account. Hang on, let me just finish. But you don't take into account any of the other things that flat earthers have brought out that have helped to explain why things may well be missing from the bottom up, and it doesn't include Earth curve. So this is the impasse that we're at, because you have a dogmatic view. Sorry?
We do. We consider them and we
dismiss them.
Throw them out because they do not match reality.
But they do.
No,
they don't match your reality. They don't match your fantasy in your head.
They don't match
You're measuring a position that moves.
Sean, let me ask you a question.
Quantified reality.
Hey, let me ask Sean a question.
No, you're measuring a position that moves on a particular day.
Hey, Sean.
Yeah, just a minute, Brian. Just a minute, Brian.
A certain amount in the sky, depending on how far away you move from the North Pole. And that geometry, those numbers do not add up correctly on a flat Earth.
Well, of course not if you just assume you're on a globe.
Not when you're comparing it to
No, they
longitude and
don't. But if I
latitude.
tell you 2 + 2
Yeah,
is 5,
You're trying
it's
to
not going
match
to
a
match
flat
reality,
curve
right?
to longitudes and
If I
latitudes,
tell, hey,
dumbass.
if I tell you, I don't want to talk to you, Brian. You're a moron. If I tell you 2 + 2 is 5, that doesn't match reality.
Hold on,
That
man.
doesn't
You're
match
trying
known
to match
reality.
up. You're trying to match up
Does it?
longitudes and latitudes to a flat Earth, dumbass. That is
No, not
spherical
longitudes,
measurements.
just latitudes. Just latitudes, not longitudes. Listen, open your ears. Close your mouth, open your ears. You might learn something, Brian.
Did you hear what Ali said earlier? That it's not 69
Yeah,
degrees
Ali,
in the north.
People in glass
nothing for
houses
you.
shouldn't throw stones, Sean.
It's 52 miles at
No, it's
45
69
degrees.
miles per every degree.
What do you say to that, Ali?
Yeah, exactly. It's at 47 degrees. That's like in the latitude of New York. It's 52 miles is 1 degrees. So yeah. So
Yeah,
why
explain that, dumbass.
It's only
What the
relevant.
hell
It's
are
only
you talking
relevant.
about? If I set my
I'm telling you.
telescope up and I set it up and it's at 39 degrees.
Did you hear what I just said there? Did you hear what Brian just said there?
Degrees, it will be pointing a Polaris. If I move 39 degrees
That's
south,
what he said,
on
clown.
the line of, he's making no sense.
You're using a program to
No, I'm
figure this
using
out.
known
He's giving you a
measurements. I'm
fact,
using
and you're just
the measurements people
whistling.
use, the settings people use to set their telescope up physically.
Address
to
what he
point
said,
in the right
clown.
direction.
All right, 1 second anyway, Brian, I just want to say something, mate. I was absolutely disgusted. I was sorry to hear about what happened to you and your family there. And I was absolutely disgusted that they clowns actually were laughing about it. I actually made a video about it. I raged for about 20 minutes about that. That was absolutely disgusting. And you thought that was funny.
Yeah, it wasn't funny at all,
fair
bro.
play
Thank
to
you
you.
very much,
happened?
Well, fair play to you for taking it the way that you did. Because honestly, I was raging, man. I made a wee, I ranted for about 20 minutes about that.
Yeah,
Absolutely
they
disgusting.
think
Anyway,
that people don't take actions against boisterous people, but in reality, man, I believe that they do, man. And some people can't handle that pressure, and they back out. You know, they
What
went
happened?
after jobs. Okay, they kicked doors in. They went after jobs. They made threats. You know, that's reality, man.
I had my daughter was threatened with rape 4 years ago when I was first in here. I had a Facebook page and had pictures. And my daughter was 12-year-old and he got threatened with a baller threatened her.
Yeah, I get ballers using my son's photo and saying he's trans. Like, there's photos on
See,
my
this is
Facebook page from the
disgusting,
day he was born, you know, naked and everything. But no, he's trans.
But
Like,
anyway,
what the
enough of the
fuck?
dark talk. It was just to say, Brian, you know, my sympathies go with you there, mate, man.
Could you ask that question again there, Sean?
I'll tell the story. I'll tell the story one day on this channel. But yeah, I appreciate it a lot, Ellie.
What did you What did you say then, Sean? You asked me a question then. Sorry.
Nothing. It wasn't important.
All right. Okay. Right. So yeah, I mean, I think with this, you know, with this new format, with the Discord that we've got going here, you know, we're getting quite a lot of Globers that are actually joining, which is good. So I would ask that both people, Flat Earth and Globe Earthers, right here, both sides, if you could just try to be a little more, well, just not as argumentative and doing the ad homs with the other side, that would be much appreciated, because I do want to try and have a more civil debates going on here than
Cordial.
this. Yes, than a lot of them in the past have descended into a shit show. So I think with this new format, I think, you know, with people coming in, people having these getting into these disagreements, but just keep it on topic. Please, no ad homs, you know, and just let other people have their moment. They need to speak, and then we'll carry on from there.
I agree. I apologize.
Yeah, I
for getting a little
apologise.
hot-headed. Sean came in a little hot, but I'll back down. I apologize.
Yeah,
Sean.
I apologise, Ranty, about the other night there, mate. I swear, it was kind of disgusting when I went back and listened to it. I shouldn't have. I was being quite abrasive there, and I do apologise for my language that I used.
Well,
so, yeah,
in all fairness, this has all stemmed from probably years and years of back and forth. We're used to this, you know, calling each other names, and you know, it's the first thing that we go to, you know, and you know, I want to try and do something different here, you know. So let's, you know, we all know Globers in the real life, we all know Flat Earthers in real life, but we don't treat them the same way, so we shouldn't really do it here.
Hey,
that's right.
So the challenge
Sean,
is there for anyone to
I
take.
got a little thought experiment to do, Sean. If I'm on a boat on the horizon and I'm 3 miles, somebody's echoing, man. But if I'm 3 miles away, okay, and you're on the shore.
Can you mute? Yeah, Ty.
Yeah, I just did.
Okay, so I'm on a boat and you're 3 miles away, right? And you see me plain as day. And let's say you got a gun, okay, and you're on the shore and you could shoot me, boom, right in the head, whatever. Okay, now I go. No, let's say I'm on a kayak, okay, so I'm just sitting right on the horizon, okay, I'm 3 miles away. Okay, you're standing up, boom, you shoot me in the head, okay, through the scope. Now I go another half a mile, or let's say 1 mile, okay, and now I've disappeared. You shoot at me, okay, and you say the bullet's going to go right over my head, basically.
If the bullet does not curve, if the bullet does not drop ballistically, it will go over your head. Yes.
So there's a wall of water in that 1 mile.
There's a 4,000 mile radius hill of water between you and the kayak. Yes.
But you hit me at 1 mile, but let's say 3.5 miles, I disappeared, and you don't think that is optical?
No, it's geometrical.
Okay, but if I go back
Of
now,
course
if I turn
it's
around,
optical.
this is my point. This is my point. Now, if I turn around to shoot back at you, okay, if I turn around to shoot back at you, I have to aim at the water, the first half mile. That's what you're saying. If it ain't optical,
direct line of sight, yes. But if you're going to shoot into the air to hit me, you're going to go over my head if the bullet doesn't drop.
my point is consider that it's optical, because I think it's obvious that it's optical. But I'm trying to come up with a better example.
If you take a string, right?
I got that one, Brian.
If I take a string and I hold the end of it, and you take the spool of the string, and it's a string that doesn't drop. It has no catenary. It has no sag to it at all. It's a perfect line. And you go out
fishing line
as you go over the horizon, and you drop below the horizon. That string is going to go into the water.
Okay. Now here's what they'd say over sag, but I got an idea. So we take that strong fishing line. Obviously, we know we're going to get sag. We get fairly buoyant line. We do it in the water, like in about, let's say, 5 foot deep, so we could work. And we take that string over 3 miles. And okay, so if we pull it tight, okay, in the water, I've already heard that idea. You know that on a ball, it will the line would be in the water if we were dead on top of the water pulling it. Okay, and on a flat earth, it would pull straight. But let's do this, okay, to eliminate the sag. So let's use some buoyant line. Now in the middle of that line, let's put a little weight, just enough to sink it to the bottom. Okay. Now if the earth is flat, when we go to pull them lines from the top of the water 3 miles apart, and we pull it, it will pull that weight off the bottom. Right, it might not go all the way to the top, but it'll try to pull that weight off the bottom. If the tension,
they've been through this, dude. This is just it's a useless. It's a useless.
Nobody's mentioned that though.
Brian,
you know what works better?
Oh, wait a minute. Let me just say something, Brian. That's my experiment. That's what I thought of in the experiment, is get a fishing line, because fishing line doesn't sag. It'll float on top of the fishing line.
Yeah, you're right. On top of the water. I agree.
Yep. And what happens is it lies in the water. Sean doesn't know what he's talking about because he doesn't fish. He's never fished in his fucking life. I've fished all my life, so shut your face. So anyway, what you do is, no, it doesn't. If you get,
I got an award in Ohio for
get 12-pound breaking strain line, right? Listen, Sean, shut your, please.
Fuck you.
Let me finish. Let me finish, please. Just let me finish.
So Randy just asked you 2 minutes ago not to do that, and you're doing it already.
Come on, let me finish. Let me explain
Who
something.
cares what he says? Just shush.
Me a not fisherman.
Sean, right? Please.
Okay, so
you're going to pick on that.
Let me explain my experiment. Let me say my experiment, right?
You say a guy isn't a fisherman?
No, he won't let me explain my experiment. Right? He won't let me explain my experiment, you see, because he's going to shout like an idiot.
Apologize for insulting me like that.
What did I call you?
You said you've never fished a day in your life. Yeah, and apologize.
Oh
for
my
that.
God.
Oh, didn't.
Oh, is that?
That's
Right,
what he's
anyway.
got triggered over.
Oh,
My God.
okay then.
Told you
Right,
he's a
listen,
known
I
liar.
apologise. I apologise, Sean.
Thank you.
I apologise. Right, let's move on now. Right, let's act like men. Right, not like soy boys. So anyway,
Oh, you mean like
Yeah,
little
I've got my
babies
fishing
who
line.
throw petty
I've got
insults like, "Oh, you've
I've
never
got my
fished
fishing
in your
line,
life."
right?
Fuck
And
you,
Okay,
Ellie.
okay. Let's listen
You
to
throw out
the.
insults all day, and when someone reverses it on
I
you,
can't.
you cry like a little baby, just like
Right.
you're
I'm
doing
here.
now.
Right. Okay.
Let me just see.
Let's get the,
Sorry.
let's hear you for a time now, LB. Go ahead.
Right, okay. So the idea with a fishing line is get like a 10-foot pole, right? And you'll get, say, for example, 12-pound breaking strain, right? You can get it at 500 meters. So you buy about 10 of them, right? And you hit it, attach it to the top of the pole that's on the beach at 10 foot, right? And then you head off in a boat and just take that all the way. You could go to the other side of the loch or stay in the boat, it doesn't matter, and take it off as far as you can. And that fishing line will float on top of the water. It won't sink or anything like that, right? The fishing line won't sink because it's so light, right? And then you can even tie maybe sort of bits of tape to it along so you could actually observe it. And then you take the boat and then you head off into the distance and then you just pull it tight after about 5 miles or whatever. And if that fishing line rises above the water, it's flat, it's simple, and it's a physical
Yeah.
experiment. There you
Allie,
go.
But their get out, their get out to that is that level is curved. They will
Hey,
just
Allie?
say that flat straight line is bending around a curve.
Yeah, they
Because
got.
it's
Yeah,
the
that,
elevation from the
that
centre of the earth.
That wouldn't work.
Like
That wouldn't.
ludicrous.
Hold on. That wouldn't work with. That wouldn't work with a physical thing like that. They can say that for light, but they wouldn't be able to get away with it with a physical piece of string.
Can I address Allie on that, please? Hey,
In all
Allie, in
fairness-
principle, that sounds good, but in practice, it won't work because line will snap before you get enough tension to pull it in any direction when you have that much line. There's a couple problems. One
No,
is
not at all, George.
every line,
Oh, yeah.
every line can stretch. The best line I found that even
That
comes
is it,
close
exactly.
for
The
doing
line,
anything like
the
that.
line will stretch. The line will stretch before it snaps, and you'll be able to pull it tight. That's the whole point of using fishing line.
No, the
It'll
problem,
stretch.
the issue that you're missing here.
No,
is
you're
unless
missing the
you can-
fact
no,
that
no,
bent.
just a minute, Allie, let
wait a
me
minute.
finish.
Okay,
No, let
okay.
me
Well,
just
hang on.
explain.
Listen, both of
Find
you
a
guys need
perfect-
to both be quiet for just a second, and let me just say this. Let me just say this, right? So, if George is right, and he says that the line will snap, or it's a globe in any way, shape, or form, it's never going to make it across out of that water. It's never going to get above the water. I think what Ali B's saying here is, look, if he's able to get any part of that water, that line to lift above the water from one side to the other, no matter how it happens, you know, whether it stretches or it doesn't, or it breaks or it doesn't, if he's able to do that, then that disproves the curvature.
Exactly.
But the
That's
point
what
is,
you
Randy,
put in the
Randy,
middle. That's
Yeah.
wait a minute,
Can
whoa.
I address this?
Please
Randy,
listen.
will you please
The
let me
fish-
address
3 miles
the
of
whole-
line, guys.
Can I just say, right? The whole point is that the line will stretch before it snaps. Bent line doesn't snap.
But
It would
will
have to
never
go
get-
straight.
No,
you will-
the thing
Allie,
that
you
you're
will
missing,
never get the
Allie,
Show me
accurate-
Allie,
bent
please.
snapping it.
So-
Show me
You will
bent strike.
never
We're not
get-
talking
Allie.
about wire. We're talking
Allie,
about fishing
Allie,
line.
please,
Wait a minute.
let me address this.
We're
I'm
talking
going to tell you
about
something you're
fishing line
missing.
that weighs
Not-
nothing.
Allie, you
You're
will
not
never
taking
get the snag
something
out.
into account
George,
here.
please.
I've
No,
taken
I
everything
was
into account.
addressing that. I was addressing Allie. Please let me. Allie, if you put a weight, in order to lift that weight up, you have to over several miles.
I'm not putting a weight. I'm not putting a weight on it. I'm just
No,
taking
you just
fishing
said
line.
you did.
Allie,
Said
I
on the
never
water.
have.
never
Brian
get
said
the
put a weight.
sag
Brian said
out
put a
of
weight.
that line, no matter what you do.
It
You
will
will never get the
stretch. Listen,
sag out of
guys.
that line.
Listen,
Ever.
it will stretch. It will
Allie,
stretch.
please.
It
Allie,
will never be
Allie,
straight.
you're missing the point that there are currents in the water. Unless you can get perfectly still water, the currents dragging on that line will prevent you from doing what you want to do.
No, it
You
won't.
will end up having to put so much tension over several miles that that line is going to snap. The closest
That's what you
line
want, and
that
it'll
you're gonna
snap above the water.
No,
if it's
it won't,
flat,
Allie.
it'll snap
Allie,
above the water.
Allie.
Well,
If
then
it's
we
not,
should try it, shouldn't
It
we,
is
rather than just
physically-
argue about it?
So if we
fishing
were
line,
to,
listen.
so
Fishing line
oh my
floats
goodness.
on water.
Right, so
Fishing line
Ali,
floats
Ali,
on
one second. Right, okay. So here's the deal, yeah.
But let me get it out.
So how much do you reckon it would cost to get this fishing line together? To get some, if you was to get
£100.
Is that all?
£100 for
Ranty?
500
I've been trying
meter.
to
I've
fucking
priced
say
everything.
something here. If Allie would
I've
shut
priced.
up,
Shut up,
you will
Sean.
never. I don't care if that
I've priced it.
table.
And
I don't care
if
that
Sean
line
can
is
prove,
steel
if
wire,
Sean can
you
prove
will
that
never get the
bent,
sag out of that line. It is
Right.
impossible.
So hold on. Hold on. I have a hold on.
the water.
Right. I'm gonna mute.
Fishing
Right.
line float.
Okay, so my point, right, so these guys are muted right now, so nobody can hear what they're saying, which is pretty cool. But I've come up with I've thought of this before actually, and I've thought of a solution that may be able to navigate the problem of the sag, and that would be to get some volunteers, people that do canoeing, things like that, maybe get a, sort of like a canoeing group, of people that have these canoes, and they can all take up part of the slack. So they can take up part of the line at stagnated parts across the lake, and that way there would never be a huge amount of drag on the line. I could understand what they're saying. If it was laying down in the water, you'd have all that additional weight over the line, which could cause the line to snap. But if the majority of the line is out of the water anyway, because they've got it in people holding it on canoes, then that would work. Let's see if these guys are still arguing. Here we go.
I'm not arguing with Ali. I want to
Allie,
idea.
Allie, can I say something?
No, fuck off. What you saying, George?
You will
George, you
never
talk.
you will never get the sag out of that line, no matter how.
It's floating. Why do you keep saying
it's
floating?
The problem with
you will never get the
problem
sag
with
out of that
it's
line.
floating, Sean.
Can you say
it's
floating?
floating?
You're setting yourself up for failure.
Ellie, if the line was floating, the problem you're going to have is a buoyancy on that line. In order to overcome the buoyancy, you're going to have to apply so much tension on that line over several miles.
That's
it's
why I
going
said
to
put
snap
weight in
on
the
you.
middle of it, and if you
No,
put
no,
it should
forget
come-
it. No.
Same pump.
should
What you
attempt
have
to
to
come
do.
out.
Will you shut up?
Go, George. Finish and
Ellie,
let me
you
rebut
have
what
to
you're
fight-
going to
Ellie,
say.
the only
Yeah, but
hope
let me
you have
rebut
of
it.
Ellie, the only hope you have of pulling this off is getting essentially a neutral buoyant line. And the line that I found that you can use is called Spectra line. It's manufactured by, I believe, Honeywell or 3M here in Minnesota. And it has an extremely high tensile strength. You can get it on the order
I want
where
to snap it, George. George, it's not about it staying together. The whole point, I keep tightening that. And if you're going to tell me that sagged fishing line will snap, you're talking a load of crap there, my friend.
Oh, the thing is with floating line,
Can I
you have
interject
so much.
something just for a
Sean,
second,
shut the
George?
fuck up.
Sean,
Why
I'm
are you
Let George
talking about
Ellie.
buoyancy?
Thing
Why are
is,
you
is
talking
that
about the strength of the line not being able to be pulled straight? Why are you not talking about that?
No, they're saying when they pull it straight, it will lift up
if the
off
line
the
was
water,
floating,
and it can't do that if it's a
Let
curve.
George speak, come on.
I don't care if you do it in air.
Right, George, you
line
carry
will
on.
never
Forget
be
Sean.
pulled taut,
Just speak over
ever.
him, mate. I can still
That
hear you.
line will never be pulled taut, Allie, ever.
Just speak.
I don't
And
care
what
if
if it
it's
is?
air, I
there's
don't care
two
if it's
issues.
helium. It will never be able to be pulled taut.
And what does it mean if it is?
Hold on a
It's
second,
physically
Ellie. I'm gonna
Listen, I want to
down,
jump in
Sean.
here, guys. I want to jump in here. I want to jump in 1 sec. So it seems to me it's a bit like a couple of the tests and experiments that I've been trying to put together. That every time we come across with a pretty decent Paige, can you mute that, please? Every time we come across with
Oh, sorry, yes.
a pretty decent idea about how to prove something, you guys poo-poo it before we get the chance to prove it. I think this test, I think Jeremy have spoken about it before in the past, actually, and it is, to me, I mean, it's a very good test. And if what would it hurt to try it? If that line doesn't snap, and if that line lifts out of the water, You know, I mean, is that what you're scared of happening? You know, I mean, I know that you're saying
No
that
one's
you,
scared of any.
you know, you're saying that you.
No,
Well, no,
that's
wait a
not what
minute,
I'm
hold
not
on.
scared of
You're
anything.
telling us it
All I'm
won't
trying
work.
to do
You're
is
telling
point
us.
out some of the difficulties that you need to overcome.
Yeah.
If you can pull
Hold
it
on.
off, great.
Yeah,
fine.
but you're telling us
There's
it won't
a lot of
work.
practical issues that have to be overcome in order to pull this thing off.
Yeah, but
But do you agree, George, that if they pulled it tight and it lifted off the water, that it would be showing there is no curve there?
Hold on, Paige. It doesn't have to lift off the water, guys. Listen, if it is just level with the top of the water, okay, let's say we have a 4-mile line, okay, it's floating on top of the water, okay. Now, we just get a tiny little bit of weight, enough to sink the middle to the bottom, okay. On a globe, if we pull that tight, the line is on top of the water and our hands pulling it tight, it's right on top of the water, we pull it tight. If it even tugs that weight in the middle upward even a little bit, that means that level in between them two strings would be up, which would mean it's flat. If it doesn't, then it means it's a globe.
You're never going to
I've got
be
the fishing
able.
line. I've already bought
You're
it.
never
I've
going
already
to
bought
be
the fishing
able.
line.
Ryan, hold on a second. You'll never be able to pull that line tight with just your hands.
You don't
If
have
you
to
pull,
pull it tight.
no,
All
just a
you
minute.
gotta
With
do
any
is nudge
part
that
of
weight
the
to
line,
the bottom.
You will never
Who
be
said you're
able to
pulling
pull
it
that
tight with the
line
hands,
tight
George?
regardless.
George,
George, what
you
the
don't,
fuck are
you
you
don't need,
talking about,
George, you
You will
don't need
never
to
be able
use
to
your
pull that
hands. You can
line
use a
tight
fishing rod.
regardless.
George, you
that's
can
what
use
I'm
a fishing
talking
rod.
about.
Could
That's
use
what I'm
No, you're not.
saying.
You're talking about
What I'm
buoyancy,
talking
dude.
about. You
Listen
have
to
to
these
have
clowns,
some
You're
man.
sort of
talking
reel
about
to take up the
buoyancy. You're
line
talking
because
This is
about
even with a
ridiculous.
pulling it
center
with your
line,
hands. It
If
doesn't
you
matter
allow
if
me to
you're
have
finish,
using
very
a machine. It doesn't
linear.
matter if you use a winch. You'll never
hold
be
on,
Right.
able to
Sean.
pull
Let
it
me
Okay.
finish,
tight,
Come on,
man.
You
guys.
have
Let me
no
ever.
idea
Come
what
on,
you're
guys.
talking about.
We're
When
having
someone
a.
lets me fucking finish, I'll
Listen,
let somebody else
listen
fucking
to
finish.
Sean, man. You're a
All right?
loony.
Quit
Allie,
whining, bitch.
contact me sometime. We
You're
can
a
talk
loony,
about it
Sean.
in private.
Hold
This
on,
is
George.
this
Hold
is
on.
a
Let me
mess.
finish.
Yeah.
Yeah, George,
Listen,
I'd
now
love to
that
Sean
talk
is
to you
ruining
if
this
we can do that
conversation.
sometime.
Listen, guys, let me finish. That fishing line, okay, that floats on water. So quit saying sag. We're talking about float, okay? If it floats on top of the water and our hands are on top of the water, right there where it's floating, and we pull it tight across the water, it will, the middle, if we're on a globe, the middle should try to nudge down a little bit. I'm not saying it's going to pull completely tight, but it will try to dip under the water in the middle.
Exactly.
On contrast, if we're in the same position and we sink the bottom, okay, over 4 miles, we sink the middle, we sink just the middle of the rope, and we go to pull it tight. Of course, it's not going to tighten all the way up. But if it nudges that weight off the bottom when we snatch it, then that would imply flatness, okay?
Oh, Lordy.
Can I support Ali idea?
Sure. Fire away.
Okay, so I thought about this idea and I looked very deep into it until I found I cannot. But I just want to support him with a modification for his idea. I hear that there is some fishing lines with the same or with the different densities. So if we select the density that matches the place where you are going to make your tests, if we put that fishing line, it will hover inside the water. And then we keep it submerged like maybe 5 inches or 6 inches
Why
below
submerge
the
it?
waves. Submerge it because when we pull it from the both sides, it will be straight. And since the
Fishing line
buoyancy
floats,
of
my
the
friend.
fishing line,
Fishing line floats on water.
no, it depends on the density of the fishing line.
12
And there's
pound
different
breaking
densities.
strain. Listen, 12 pound breaking strain fishing line. I know I've priced everything. I've got the experiment in my head. I know exactly what I'm doing. I've been fishing.
Okay.
What's that?
Hold on. Okay. Just give me a minute.
bought 50-pound test.
Okay, give me a minute. Just a minute.
I don't
Maybe
use
I'm wrong.
50. You don't need 50.
Okay.
You can do 12 pound, but 50 is good. But 12 pound is lighter. But sorry, carry on. Who was talking now?
Okay, so according to my understanding, maybe I understood it wrong, but if you look into it, just see if there's different densities. That would help you with your experiment. Thank you.
I've looked into it. Listen, I've got it planned in my head. I've been fishing all my life, man. From shore, from sea, everything. I know what I'm talking about with fishing line. I know exactly that's why it's a good experiment. And you want it to snap. And if it snaps above, look, the fishing line won't snap when it's curved. You show me a curved rope snapping before it goes straight, or curved anything going snapping before it goes straight. There's no weight in the thing. There's no weight in it.
Or at least damn near perfectly straight, at least close to straight.
Yeah,
I
but
agree.
Yeah, but Brian, the thing is, it doesn't matter if it snaps, if it comes above the water. But the point is, the fishing line will start off on top of the water.
I agree. That's why they're saying
Right.
it won't prove nothing. They don't want us to do it.
No. Well, we'll just prove them wrong because it won't sag. It's only going to snap when see fishing line stretches, right?
Yeah.
Right?
Sean kept
Fishing
saying
line
sagging
stretches, right?
when you're
It will
clearly telling him that floated on the surface. He's talking about sagging. I'm like, what do you keep talking about sagging? Ali said it will float on the surface.
Fishing line does float on the surface, as a fact.
If there's any curve at all, if you've got one guy on the one shore and he's got a 10-foot pole, and you've got another guy on another shore, however far away, with another 10-foot pole, and your fishing line attached to the top and it's making like a U down and touching the water, when you pull those poles back, if you're on a curve, then the fishing line should never raise up and pull taut. So if we can get it to pull taut at all, then there's no curve there. It's pretty simple.
Yeah, and the thing is, it's a physical experiment. No optics, no nothing, man. It's a physical experiment. It's the simplest experiment you could come up with, and that's it. And that would just knock
Yeah,
this
it sounds
out the
good
park.
to me.
You know what works better than any line or type of physical object? Water.
That's what I was going to say.
But they won't accept water
level
is curving, though. They
Who
can't say
cares?
Exactly.
Who cares what they say? They're going to say
But
something
I
about the
do.
fishing line.
I do care because, but listen, the thing is, if you do it with if we do it with water racky or whatever like that, they'll just say it curves. Exactly what Brian says. They will not be able to debunk the fact if that fishing line comes in, if it even rises above the water, even with the sag, even if you want a sag, but it won't sag when it snaps because it stretches before it snaps. So you be able to get it as tight. You want it to snap,
Right.
Because then you know you've pulled it tight.
Yeah. So what he's saying,
You
Rocky, is
understand?
if we're on a globe and we pull it tight, then that water should try the middle of the line should at least attempt to pull underwater. Okay.
Yeah.
Yeah, exactly. One side should be going
Listen,
under the
I'm
water.
just curious why. Don't you know with Jaren figured out that this wouldn't work because anytime you pull that.
But he's a dickhead.
Here's the problem, Travis. He didn't use shit that he didn't. No.
Sorry for
he
swearing,
didn't come
Ronnie.
up with the concept. He didn't come up with the concept of using floating line, man. That's why he deserted that experiment.
Yeah, but that's not the point. Hold on, but that's not the point. The point is, okay. The point is when you were pulling it taut, it would snap.
No, well, actually, it doesn't matter if it snaps. If it snaps above the water, right? If it snaps above the water,
yeah, it's got to be below.
If it
it's got to be
below the water, it's a globe. End of
Yeah.
story, man. So but the whole point about it is that fishing line will stretch. That's the whole point of using fishing line. It will stretch straight before it snaps. It won't snap in a curve.
Make a
You
test.
understand?
Do it over land
get that?
on telephone poles, high off.
No, I'm doing it over
Do it on
water.
that. See if you can pull it tight. See if you can pull that line, whatever 100-pound test you want to use. We got a 100-pound test out here.
You'd like that one.
See if you can't pull that line tight.
Sean's got a point. You could.
Please don't interrupt. Please. Right.
See this?
Right. This is ridiculous. Right. Sean was, and I have to defend Sean here. Listen. Shut up, Sean. Sean was speaking, and you lot just jumped on him. Please let him finish his point.
Thank you. You will never get that line tight. I don't care how you do it. I don't care what machine you use, what material it's made out of. Fishing line, steel cord, steel cable, whatever. Everything physically has a catenary, has a sag to it. You will never get that sag out.
But you're going to get to a point. You're going to get to a point where the curvature comes into play and cancels that sag out.
Exactly.
Derp. Come on, Sean. What are you, new? Are you new, Sean?
You will never get that sag out, no matter what you do.
Sean, listen to me. Hold on. I got this.
There is no sag.
I got this.
Okay,
Sean.
one last thing. I have a test. Why don't you do it 1 foot under the water and just pull it tight under the water, and then measure it from the center.
Exactly.
No, that's just complicated.
No, it's not, because then there'll be no.
Up, it's flat.
Hold on, wait a minute, because then there'll be no issues with any kind of additional weight on it. Then it will be inside the water, and you'll be pulling it tight in the water. Yeah, I know, but as you pull it tight, it will.
Guys.
Yeah, but as you pull
Guys,
it.
fishing.
Oh my God! What's the point? I'm speaking. So when you've got it a foot under the water, right, and you pull it tight from both ends, then it will just pull it through down into the water, yeah?
Except for the fact that you may have currents that are going to really cause you trouble. You're going to have to find a body of water that's very still in order to do that.
I've been thinking about this. Go ahead, go for it. And
I'd say, try it.
When they go for it, they have to accept their results as the shape of the earth.
Yeah, it's not going to happen the way you think it is, Sean. Listen, hold on real quick.
Explain how you're setting yourself up to fail, but go ahead and do it. And
I'm a bit scared about doing it. This is the whole point, Sean. I agree with you. If I do it and it does snap under the water, I'll bring it. Like, wait a minute, Travis. I'm going to agree with you, Sean. I swear it on my daughter's life. If it snaps, I'm going to, whatever happens, I'll show the results of it. I won't hide anything.
If that line is above the water,
do it.
It has to be above the water. It can't be in the water.
But I need a few people to do it with. That's why I'm heading off to. That's why I'm going to try and head off to America. I've got a few people there that are interested in doing it. That's why I'm planning to come out. Hopefully, cross fingers. If
Ali, come see me, Ali.
Jacksonville, man.
No, I said it first. Ali. Come see me. Come see me, Ali.
Yeah.
We're all going to meet up together.
If both ends of that line are out of the water, above the water, the center of that thing has to be out of the water.
I am. You can do what you like. I'm doing my experiment how I see it.
The whole thing has to be out of the water.
And I'm having them out of the water.
You're setting yourself up to fail, Ali.
Ali, if you
do that's fine. That's what you think.
The sag of that cord. The
sag of that cord. It's fishing line, man. What's wrong with you guys?
You would be better off doing this in one of the long canals you have in England rather than
Denmark
to America.
No, but I've always wanted to go to America, dude. I've always wanted to go to America.
You have to make sure then that you probably use an inland lake. Doing something like this on the ocean where you have swells and that will totally mess everything up.
I've already. No, you can actually do it up a shoreline. You just need to find a long enough shoreline and do it along. Because you've also got to remember there's people in boats.
Tides and
it's a bit dangerous. No, but I'm saying it's a bit dangerous stretching fishing lines across a body of water with boats travelling back and forwards. So it would really either be on a lake or...
Do you guys have those big reservoirs in, how they have those big
Loch Ness would be the place. Loch Ness would be the place, I think. That'd be a great place to do it.
Well, actually that. You could actually do Loch Lomond. Loch Lomond as well. That's about 20 miles long or something like that.
Yeah, the reason I say Loch Ness is that there's a lot of outcrops there that you can go 3 miles, between one and the next, and it doesn't interfere with the fishing lanes or the boat lanes or anything like that.
Yeah, but I want 5 or something, Ranty. I want to do 5 or 5 miles or 10 miles, just because they'll say, it's only 3 miles or whatever. I want to take it further.
Yeah,
I want to make sure.
Do you realize how big of a mass fishing line to get 10 miles would be?
Yeah, it'd be a lot.
You'd have to fit this on the back of a flatbed truck.
No, it's not,
Are
dude.
you joking?
Hold on now. I got 3
That's
miles,
rubbish.
and it's only 6 spools, dude.
Okay,
there you go.
Okay, well, let me shout out to Aaron Armstrong. He says, no ball is poo-pooing your observation. We just know the line will sag and then break. Just trying to save you £100. Well, I think Ali said that it's £100.
It can't break.
He said it's £100 for.
Snag.
Hold on,
it can't
for
sag.
fuck's sake.
It won't sag.
He said that it's £100, but I think that's for 500 meters. Was that right? So if you were going to do
no, that would be for the whole lot. That'd be for the. I think I worked out 5 miles. That would work out at 5 miles. It's about £100 for the. For the fishing line.
couldn't you do some tests and say, well, okay, then let's do it over a mile, And what's the breaking strength of this? Of the one you was thinking about? Was it £12?
£12 breaking strain, yeah, because it's light.
So can you get a £4 breaking strain and try
Yeah,
and do
yeah,
it?
yeah.
And, you know, and try and do it over a mile, and just see whether the proof of concept works over that sort of distance.
Yeah, that's a good idea. But I would, yeah, that's great. But I was just thinking of going the whole hog and just saying, right, to hell with it. It's only £100. I can get a hold of we can get a hold of a boat or something like that. That's all it was. I don't care. I was just going the full hog straight away instead of doing a. But that's a great idea. Do a proof of concept.
Let me respond to that super chat. Yeah, they would love for us to do it over land and say, yeah, see that sag, that's Earth curve. You know, but I don't want to hear no other person say sag because it is going to be floating. So if we do it on top of the water, and we sink the middle and it even tries to go up, then it means the Earth is flat. If we do it on top of the water and we pull it tight and it even tries to go down under the water, the middle of the line, then it's a globe. It's that simple. It doesn't have to tighten all the way up.
Do multiple. Yeah, do the multiple test. Do it with the weight in and without the weight and all different ways to do it. Don't just... Yeah, we could do it with the weight. I was thinking, you know, Timmy Osmond, but what's that lake that he does?
The Great Salt Lake.
Shallow, isn't it?
Just to be clear, what I was talking about is just enough weight to barely get it to the bottom, in the middle. So what we're observing is the middle of that line. You know, so we do it at the top of the water, so there's no sag, okay, and then we do it with the middle of the line, barely sink to the bottom, just enough weight to make the middle of that line sink. If they're just flat,
what
when we
about
go to snap.
Timmy Osmond is Brian? Well, that Tim Osmond, he took photographs. What was that? That's that shallow water. Where was that? He done the
Is that like Pontchartrain?
No, not Lake Pontchartrain. It was the salt flats or some water flats or something like that. He done, I think.
The Bolivian, no, he's in America.
Was it the Salt Lake? Yeah, the Salt Lake. I mean, you could walk that. You could get a little, maybe a wee canoe or something, because it's only a couple inches deep or a foot deep, and then you could just take it off the line.
And I got a little boat, man. I got a little boat, a little skiff, and I got the fishing line. If you do come to America, let me know if you're anywhere around Florida.
Oh, well, you know, if you've got that there, and we can move up to, I'm sure we could get some kind of funding to actually go up to that salt flake, because I was talking to my mate Chris, and we were thinking because I was talking about the experiment tonight, and we were actually thinking of going to that place that Stephen Hawking's done the experiment with a helicopter. Do you remember that one? And do it there.
Yes, I do.
Wouldn't that be ironic?
But hey, I already got a
Wouldn't
spot
that be
picked out
ironic,
here.
guys? That was Chris F.E. Jackson's idea, by the way, but wouldn't that be ironic doing it across that stretch of water? Because a whole helicopter disappeared.
I had a Glober come in several weeks ago now. I can't remember who he is, but he did turn around and tell me that lakes don't curve. It's only oceans that curve. Lakes are flat.
What the fudge?
Yeah.
What?
So if this was accomplished over a lake, I'm pretty sure that the rest of the Globers would turn around and say the same thing.
Randy, that's bullshit. You know that. I measured curvature over a large lake here in Minnesota, so that statement is bullshit.
Well, it's not bullshit.
Like
That is somebody did come in and say that, and I got him to clarify it as well.
You measure perspective.
Oh, the man is wrong.
Well, that's just stupid things you guys say, so we're just repeating it.
Press 1 in the chat if you remember the guy saying it, because I repeated it 2 or 3 times and he responded every single time with the same reply. If you guys remember that in chat, press 1.
Wrong. The guy is simply wrong.
George, can I ask you a question?
What would you do, George? What would you do, George, if the fishing line snapped above the water? What would you do then?
He'd make up excuses.
No. Well, let him answer. Let him answer. What would you do then, George? What would that do to your world?
I get totally what your experiment is. If you tell me what your experiment is, then I can answer that. It was too much of a mess trying to listen to everybody talk over one.
All right, I'll tell you what it is.
I don't know what you agreed on.
Right, well, let me tell you then. Right, okay. So what my experiment is, is getting a pole, sticking it in on the beach, right at the water level or whatever, tying a fishing line maybe to the top of the pole or whatever at a certain height, and then just running it off into the distance as far as I can, maybe to another shoreline, get a fishing rod or some way that we can tighten the string, tighten the rope, have it up at the same height as what it is on the other shore, and tighten it and see if it snaps underwater. It's a ball.
Wait a minute. You said this is going to be above the water. I thought you wanted the line in the water.
No, that was Brian.
On the water.
On the water, because fishing line will float.
You said
I can
you're
run that
tying
in a
it.
layer and it won't sink.
Just a minute, Ali. You just told me you're tying it on a pole above the water, a certain height.
Yep.
What is it going to be?
Ali,
It's above the water.
Don't let him confuse with the other experiment. Just yours is good. It's above the water for the first one.
Right, it's above the water.
No, explain it. You're either going to have the line on the water, or above the water, or in the water.
No,
Above.
listen. Right, listen to me. Let me nobody interrupt, please. Let me explain
I've heard
it to
three
George.
different things here. So
George,
explain
right, let me
clearly.
explain then. Right, okay.
But do
right,
so clearly.
Okay. Right, okay. So I get a pole, stick it in the ground. It's 10 foot high, tie it up at a 10-foot mark, get the fishing line and run it off into the distance, right? Run it off into the distance, go onto the other side of the shore, whether it be 10 miles away or an outlet or whatever.
Above the water. Then the
Will
line
you
is
listen?
above the
Will you
water.
listen? Will you
See
listen
what
to
he's
me?
saying. Go ahead.
Right. Okay, so now we've done that. But I'm going to take it a distance that if it's 10 foot, I'll make sure that if it's whatever, it would be impossible if it was a ball for it even to be above with the drop. If you add in the drop, if you work out the distances, if for example 10 miles, there'll be a 10-foot drop, right? So I know then.
No.
Right, wait a minute. I know then.
60
Wait,
foot.
I know it's wrong.
60
Listen.
foot.
Right, it's 60 foot. Okay, so I take it 10 miles, right? So I know there's a 60-foot drop there, right? So if I run that line across to the other side of the shore or whatever, 10 miles away, right, and have it above the water and I tighten it, it would be impossible. Right, George, 1 second.
I agree what you're trying to do, but there's a problem that you're missing here. 10
And what's
miles
that?
line, you're never going to be able to get the sag out to the point where
But wait a minute. But the fishing line, excuse me,
George,
the
you're just
fishing line.
stupid, man. You're just
Right, listen,
dumb.
the fishing line will be sat on the water before I tighten it. It has to, because it floats.
Okay.
So as soon as I
it should
tighten
nudge
it,
one way or another, whether it's
it'll go one way or the other.
Exactly.
Exactly.
One side or the other.
Shut up, Brian.
That's
Brian,
it.
Shut up,
will you-
George. I'm trying to
Brian-
clarify because you're a blockhead.
Brian,
He's
will you-
right.
No, let Ali speak to me. I do
Exactly.
not
I'll
want to talk
repeat
to you, Brian.
what Brian said. Exactly what Brian said there. If
Didn't hear
it
a
snaps
thing what
underwater,
Brian was
or if
saying.
it tightens under the water, I'll have to accept that it's a ball, especially if it's over 10 miles. But if it even comes off the top of the water as it tightens, it'll obviously have to. And even if it sags, it doesn't matter if it sags, because it has to go under the water if it's a ball. If it's not a ball, right? So there you go. So now my next question is, what would you do then if it did?
Okay.
If it did.
All right. Now let me get this straight. Okay, you're going to have these poles. You're going to tie the line on both ends about 10 feet above the water. Well, let's make it something practical. Say 3 feet. Okay.
All right, 3 feet. That's fine. But we've got to account for waves and swell and stuff like that.
Well, yeah, that's why you want to have an inland lake like early in the morning when it's quiet.
Yeah, but that's why I want to
that's
get the
beside
height.
point. I mean, these are
Yeah.
logistics you can work out. But
I've worked
okay,
them
so
out,
you're
yeah.
going to tie the line off, and then you're going to start pulling the line. Now, if you're 3 feet above the water,
Yep.
On both ends, then you're going to have you're going to have to be out. Let's see it. 3 feet, 6 feet up gives you 3 miles. 3 feet. Okay, so you're going to have probably, gosh, I would say, well, I could calculate out, but about 4 miles of line would probably be sufficient.
Right. There you go.
Well, I can do a proof of concept if you like, guys, because I'm just saying I've just found a place that's not far away from me. It's 1.3 miles, so I reckon I could do a proof of concept. I can buy a few different weights of tensile strength of the fishing line, and I can just test it across that 1.3 miles, and we'll get some kind of breaking point there, and we'll see whether or not it works.
The thing is,
Wait, I got a question, George.
No, but here's the good thing. I can use my drone. To fly it across.
Can I just address Allie on this? Say, Allie, you have 6 miles of line, okay?
Yep.
So that at 6 feet up, or tangent to the water is 3 miles. So 3 miles each way. So if you drop it down, say to 2 feet above the water, 2 feet, then you should
George, 6 miles will be 26 feet, bud.
Oh, no, you're going half that. From the center, 3 miles each way. So at 3 miles each way, you have a 6-foot drop. So, thing
George,
is,
why don't you put your flat Earth hat for 1 second on and assume that it's flat and then.
What are you on about, George? You'll have a 6-foot drop.
I'm just trying to address Allie. I'm trying to.
Yeah, but George, how do you?
The thing is, Allie, say at 6 miles, what you want to do, you want your line probably be no higher than about 2 feet above the water, so that when you pull it tight, you will be able to determine whether it's going to go into the water or not.
Yeah, you understand my concept, man? You understand my concept of floating in? Here's my concept. As we go 3 miles, we float the line on top of the water, okay? And we have a winch at one side, level with the top winch at the other. Okay, we take just enough weight to sink the middle of the line in between that 3 miles. We sink it down. If we pull it tight and it even tries to snatch upward, okay, if the middle even attempts to snatch upward at all off the bottom, then we know that a straight line, and we know that the Earth is flat, okay? Now, if we have them winches on top of the water in the middle of that line, we pull both sides tight, the line's floating on top of the water, mind you. And if the middle of that line tries to pull underwater, even a little bit, even like 4 or 5 inches underwater, then we know that there is curvature.
I'm not going halfway. I'm not going halfway though.
Ranty, or not Ranty, but Allie, normal fishing line would not be appropriate for this test because
it would.
Too much. No, it has too much buoyancy because.
But that's the whole point. But you're missing the point.
No, that's the problem.
George, we use multiple lines. George,
what the hell is wrong with you guys? Why can't you? But why can't you?
My God, Allie, listen.
We use multiple lines.
Put your listening ears on a second. Just put your listening ears on.
That's fine. We use multiple lines.
Yeah, can you just one at a time? This is getting ridiculous.
But this is simple. I'm out here. I can't be bored with this. I'm out. Thanks, Ranty. Anyway, my head's splitting way. It's such a simple experiment. It's getting all complicated. Yeah. All I want to do is run a fishing line from one side of the shore to the other side of the shore, and if the water, when I tighten it, the fishing line rises, it's flat. If it goes down, never mind try to sink it, never mind winching it from the middle of the water or anything like that. Just do that. That's all it is. It's so simple. Fucking why are people? Oh, sorry. Why do people try to complicate such a simple experiment, man?
Agreed.
It's so simple.
Allie, I'm not trying to complicate it. I'm just trying to point out that you need to find a line that's nearly neutral buoyant. If it has any significant buoyancy, like your normal fishing line.
Fishing line sits on the top of water. What's wrong with you, man?
Allie,
I got 3 miles that floats. Just so you know.
My
God.
I got neutral line.
To have is to overcome the.
George, have you fished before? George, do you know what fishing line is?
Right, this is George. I think you need to look into this.
Do it your way. No, do it your way. I encourage you to do that. Then come back to me when you have your failure.
Oh, listen.
Right, listen. I'm gonna round up, guys. I'm gonna do some final thoughts now. So, Ali B, seeing as you're here, you're top on the list. We'll go through the list and we'll do final thoughts. Ali B, your final thoughts, please.
All right. Yep. Okay. Yep. Great conversation. Great show, Ranty. Thanks for giving us this little place that we can come. It's the only place on the internet at the moment, on YouTube at the moment, and I appreciate you taking the time to do this and allowing us all in here, because we'd be kind of lost if we didn't have this place. So good on you, mate. And good luck to everybody. All the best to everybody. Blessings to everybody, even ball earthers, even the ones that don't deserve them. All right. Thank you, and good night.
Okay, so Brian, your final thoughts, please.
Yeah, my final thoughts is like a question, okay? Man, I had this concept a long time ago, and I threw it out there on Globebusters when I first joined, when I first started looking at all this stuff. And then Jared come up with the test he was going to do, but I don't think he ever did it. But he didn't listen to the whole thing, and that's the problem. But okay, so if we have we're on a shoreline of a lake, we're 3 miles, okay, and I already have the line. It's neutral. Okay, it's 50 pound. And okay, so we have the line. It's in 2 foot of water approximately. It floats on top of the water. Okay, we pull it. If I take just enough weight in the center of that line, so at 1.5 miles, I sink it down to the bottom. Let's just say it's in 1 foot of water. Okay, 1 foot of water. We sink the middle of that line down 1 foot, just barely enough weight to sink the middle down. Okay, if we pull it tight from each end, okay, and that weight tries to bounce up off the bottom, what does that imply, George?
Right, okay. No more questions for now. Have a think about that, George. Maybe respond to it in your final thoughts. Bungie, if you want to say anything. No, guess not. Right, okay. Croxy.
Yeah, I'm so sad that this happened on your show, which is a beautiful show, and I'd like to come here, and sometimes I don't get the chance to talk because of everybody, not specific side. But what happened is, I see a strategy from the flat Earth. Everyone is ready with things to spoil your experiment, and the current theme is the horizon is not at the same location. And when I tried to explain how I measured the circumference of the Earth without depending on the horizon, I was totally dismissed and I was shut up. Thank you.
Okay, George.
Yeah, I was just trying to point out to Allie that if a line has any significant buoyancy where it's laying on top of the water due to buoyancy or surface tension, that by the time you start tightening it up and getting it taut, it's going to snap and you're not going to be able to conclude anything because you're not going to be able to parse out what was due to curvature and being in the water versus just trying to overcome the buoyancy forces. One of the best lines out there that I found that I was talking to Jaron about is a spectral line. It's nearly neutral buoyant. It has a density of like 0.98 that of water, I believe. So it's going to be probably the best line that you can find to use. Using ordinary fishing line just has too many problems, and it's going to the test is going to fail or be inconclusive because there will be too many issues that needed to be overcome that weren't taken into account, and so it'll be a null experiment. But Allie and you guys are welcome to try all you want without thinking this thing through properly. There's also water currents that are going to cause drags on the line and many other issues that you need to think through before you throw money at this in time. But give it a shot. Catch you later.
Okay, left lane.
Hi, Randy. Can you hear me?
Yep. Yeah, if you want to do your final thoughts there, left lane.
Yeah. Okay, here we go. You've got monofilament and fluorocarbon fishing line. You've also got braided fishing line. Some of those are buoyant, some are not, some of them float. But I would bet that you couldn't pull 100 feet of fishing line and get the sag out of it. I wish them luck, and I'd like to see them do the test, but I think it's going to be a neutral result.
Okay, level world.
Yes, guys. This discussion is endless. I think. Demand scientific evidence from them. They have not provided any evidence so far. So, just guys, cut it off. As soon as possible. Don't go. To Narnia, as would say. Just just be patient, and I think we can do it. And don't give them even 1 millimeter of our grant. Thank you very much.
Paige?
Yeah, nothing to say really. I'm glad that more ballers are joining to talk to us. You know, I appreciate their input to this. It just gets a bit frustrating when all we've heard for months is, oh, flat earthers are so lazy, flat earthers never do any experiments, blah, blah, blah. And as soon as we come up with one, they're already making excuses before we've even tried anything. They're making excuses for why it won't work or whatever, rather than waiting till we're finished. But yeah, if they, you know, whatever input they can give will always be good, so that we can, you know, try and make it an experiment that will be acceptable to both sides. And I think that's the most important thing, making it acceptable to both sides, not just, you know, one or the other, not just assume you're on a ball.
Okay, cool. Rocky Alive?
Yeah, thanks, Randy. I was just trial and error is a good thing. You go do tests, and if it doesn't work out, try something else. But yeah, water's the key. It's always level.
Cool stuff. Yosi?
Hi. Actually, I didn't say anything during the conversation. I joined because I wanted to talk about this religion thing, but quickly after that, the conversation context shifted away to other places. So my English is not that good, and so currently I remain silent. I can say, as an outside observer, I try to put myself in an objective place, even though I'm a global. And it feels to me like I'm not judging anyone, you know, in specific. You know, I'm just trying to be general. I think that there should be a bit more of respect around that. That's my opinion. I don't know the people. I don't know the context. I don't know why someone is angry about someone. You know, I don't know all of that. So maybe I'm missing something. But still, I mean, if people don't respect each other, so what's the point of even talking? Like, why are we doing that? I don't know. So, like, I felt like I have to say something. So, I hope, I don't know, maybe that's something I get.
No, I appreciate your input there, Yosi. Thanks very much.
Yeah, sure.
Okay, right. So all you guys have done your final thoughts. I'll do mine. Here we go. Yosi brought up an interesting point there, which was, you know, why is there so much animosity between what seems to be, you know, people with an interest in, you know, the shape of the Earth, you know, flat globe. Some believe in the concave, you know, but why is this animosity? Well, it's something that's been around and been ingrained in us for years, and you know, a lot of the people that you hear on the panel right now, a lot of these people have been in these debates for years, and they know each other, you know, back and forth. They've got what you can call beef with them. Now, I do have another channel inside my server called Beef, specifically for that. So, you know, so that if people have got beef with one another, whether it be they want to talk to each other or they want to actually have a, you know, a verbal chat as well, two beefs, one written and one verbal, so they can get it off the chest. But yeah, this has been a long time coming, guys. I mean, you know, flat earthers and globers have been arguing for years, and you know, it seems like it is a circle jerk, to be honest. It seems like it goes around and nothing gets resolved. I aim to change that. I aim to do an awful lot of tests, and I think Ali B's at that point too as well, and I think flat earthers are at that point where we're trying to step it up. You know, we're trying to find new ways that can satisfy the globers. And as much as that George was raising his objections to this particular test, well, all of those tests were on the failure of the test to, you know, to actually make the line, you know, get out of the water if it was flat. I think George is missing the point. the point is that if we overcome all those points, the tide, the swell, the chop, the drag, you know, all that kind of thing, if that if that line breaks the water and raises above it, that's it. It's game over. It proves that it's flat. So, you know, and I know that he's turned around and said, yeah, okay, we'll go ahead and try it. Well, yeah, I mean, we can try it. And if all those things do happen, and let's say the line breaks, or let's say that the swell takes away the line, okay, so it didn't perform how we expected it to, we can always address it at another time. But if he goes out the first time and encounters all those problems, and the line breaks the water and rises above the water, then, you know, I mean, that's pretty much game over. I mean, once it's gone out of the water and it's raised above it, it's done. You know, that's the proof that's been needed. And I think something physical, you know, because optical is always this argument. We're always arguing about the optics of stuff, you know. I mean, it's this refraction, that. Something physical, something tangible, something that we can actually demonstrably prove, and the line breaking the water would be a good test. Obviously, there's a lot of things to prove. First, you've got to prove proof of concept. You know, will the line take it? You know, I'm happy to do some tests locally with some fishing line of varying tensile strengths, just to get a proof of concept. Because if a 4-pound line will handle a distance of a mile, then a 12-pound line will handle a distance of 3 miles. You know, and a 3-mile test is more than enough to get a result. You know, I know Ali wants to go 5 miles. Let's just go 3. 3 is more than enough. As long as it breaks, as long as that line is pulled up above the water surface the whole length, then there can only be one conclusion, and that the line certainly is not curving to earth curve. It has basically gone across a flat and level water. So so as much as the Globers want to argue about this particular point, and I can understand they want to argue about the point, simple fact is, if the test works, you know, it just works. And that is scary for any Glober, to know that you can have something as definitive as that. Right, okay guys, I'll be back later this week, I'm sure. Maybe tomorrow, maybe the day after, I haven't decided yet, but I will be back. I'm trying to get 3 or 4 shows in at least this week. And yeah, thanks everyone for stopping by. I think I had 170 watching at one point, which is pretty epic. Hope you guys decide to return. Appreciate the Globers showing up and putting their input in. It's nice to get, for the most part, a pretty civil conversation going, apart from a little bit that just went haywire for a moment. But you know, hopefully in time we'll get to iron those out, because the people will understand that in this format, I just want a civil conversation. So that'll do for me tonight, guys. Yeah, thanks for everybody that supported me with the super chats as well. And yeah, I'll see you all in the next one, guys. Take care.